The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, everybody, and this is Dr. Mansour, and today is June 5th, 2021, and this is a transportation session, the one I supposed to have last week, but I moved it because the Memorial Day break. I thought that a lot of people will be interested, but let us do our best, whatever the number of participants today. The class will be recorded as usual, and it will be loaded on our website. So today I'm going to cover the transportation. Already I emailed you the chapter of the transportation. I hope that you get a chance to print it. And probably I will add another session or so So this session here today, 6-5. Unfortunately, last week we didn't do. I did surveying problems. I solved surveying problems because of the Memorial holiday or the Memorial weekend. So I will try to add another session and try to capture whatever topics. But today we are going to focus only on the transportation, which is very, very important chapter. And I did my best. And the chapter I emailed you, it is based on certain references. Already I showed you them before. So, for example, this is the highway capacity manual, which I showed you last week. This or the week before that, the HCM, the highway capacity manual. I have all these original showed to you, but this is a summary of the references. The highway safety manual, the HSM, and the geometric design of highways and streets. This is an older edition. But this is what the NCAA they are using. There is a newer edition we are using for the transportation VM. So this is a geometric design design for highways and streets. And this is another book published also by the same agency, AASHTO, the Roadside Design Guide. This is a 4th edition. And this is a Garber and Hoyle book, the one they are using. They are using an older edition, which I showed you last time, which is a 4th edition. This is what they are using. This current edition is called Enhanced 5th edition. So this is a Garber and Hoyle, one of the textbook that I have been using since I started teaching 30 years ago. Okay, I used the 1st edition. This is a 5th edition, by the way, 5th edition. So anyhow, so I extracted whatever information from here. Obviously, they provide us with the equation. This is the chapter I emailed it to you. I hope that all of you printed. This is chapter 13, based on the numbering system of the current NCAAS test plan. Did you print this? You didn't email me. I told you to email me yesterday, but for some reason you forgot. So, there is one book and one more book. Jeez. So based on the NCAAS, the FE reference handbook, as all of you know, this is the one I showed you every meeting. 10.0, it is available on the website. You can download it or you can purchase this directly from the NCAAS. So chapter 13 is the chapter dealing with transportation. If you go to the end of this NCAAS, you'll find that they have 14 chapters starting July 2020. As you know, they changed the arrangement of the topics. So this is a current one, and the current exam will be based on these topics. So math and the statistics, ethics and the professional practice, economics, statics. Statics, we cover the statics, as you know, and you have a chapter for that, and they emailed it to you. And dynamics, I didn't cover it. Mechanics of material, we covered it very, very well. Even I spent 2 additional periods talking about mechanics of materials, because it's very, very important chapter and the basis for a lot of things that you are going to see it later on for the FE and also for the PE. And materials, I covered that also. It was a very good chapter, and we talked about that. Surveying, I covered that. It was a very good chapter. Also, I extract the material of the surveying topics here from my 4 surveying textbooks for the PE. And today we are meeting with the topic, or we are going to handle the topic chapter 13 in the same order as NCAAS they listed, which is a transportation engineering. I know I covered portion of it before, and I'm going to record it again from the beginning. So bear with me, okay? Probably are going to take 4 hours, continuous 4 hours. Maybe I will give you a short break around 10 o'clock, but we need to cover the transportation today, and after that we are going to end the session today, and I will add another session to go over construction and geotech. I'm almost done with these 2 chapters. They are also very good materials, and you will enjoy it at the moment. I have 3 books, construction for the PE, so I extract whatever I need based on the topics listed here. And the geotech is also, we cover this for the AM, for the PE, and a little bit in the afternoon. So these 2 chapters will be covered together. I will try to squeeze 1 more day for you guys, and hopefully this will be and hopefully the book will be ready. I'm working very hard to get this book ready, but as I told you that I'm extremely busy, and I hope that in the next, I don't know when, next month or so, I hired more assistants to help me, more engineers or more students to help me. So probably this will give me more time to wrap up the book. And when the book is available, it will be available on our website, and it will be available on Amazon, and you can purchase if you like to purchase it. And after that, I'm going to offer the class based on my book, because I said that I prefer to use my own books for all subjects I'm teaching, FE civil or transportation or construction, seismic surveying. I found it's much easier for me to follow my books, and they are available on Amazon, and the rating, you are very welcome to go and see the rating by yourself. So going back to the transportation, according to the NCEES, which all of you know, the exam is a CBT, computer-based test. You have to make an arrangement with the testing agency or the testing site through the computer, and you have an account with NCEES, and you reserve the time or the slot that is available to you at your location. And the number of questions according to the NCEES, they are saying between 9 and 14 questions related to transportation engineering. And here are the topics listed: geometric design, streets, highways, and intersections, pavement design, thickness, subgrade, drainage rehabilitation, traffic capacity and flow theory, traffic control devices, and transportation planning, which is the last topic, traffic forecast or modeling, okay, traffic forecast modeling, safety, and trip generation. Those are the topics listed by the NCEES. But you will find this chapter, like the rest of the chapters, I go with the reference book, the 10.0. So when if you open the book, if you have the book with you, the NCEES, you will find I provide you with the page number. Because this is the only material you are going to see on the exam. You are not going to see anything else. So these are the equations, and here are the parameters of these equations. So if you go to page 298, for example, of this FE reference book, 10.0, again 10.0, 298, you will find the chapter or the topics for the NCEES of the traffic or the transportation. Here it is. So this is page 298 of the FE. And you'll find that here are, for example, and I took each section as they appear in the NCEES. So this is what you are going to see as a PDF. As you know, they are going to give you, okay, the screen, and the screen will be, at least some location they have double screen or dual screen, I don't know. Check with this testing place. But to the best of my knowledge, it's only one screen, and it will be, okay, split. You will find the 10.0 here, the reference book, and this the other side of the screen, or the other half, is going to be the questions. So the only thing that you are going to see here the PDF of this book, and you need to make sure that you really understand how to search, how to maneuver between pages, and how to locate the keywords and search for keywords, because the book is very thick. It does have all disciplines, mechanical and electrical, industrial, general, and so on. So you need to go to the proper section, which is a civil engineering, if you are looking to traffic, for example, or transportation, and so on. So So what I did, I took each section. For example, this is a traffic signal timing. So I took this and I put it in a box. And this is what you see. This is what you see with some kind of improvement or enhancement. So this is the traffic signal timing. This is the first topic listed. And here are the equations and the parameters related to this equation. So the first equation is talking about the yellow time. And the second equation is talking about the all red. And the third equation is called the minimum green time for pedestrian, G sub P. G sub P. All these parameters are listed here. So if you look to the Y, the letter Y, you'll find that this is the length of the yellow interval to the nearest 1/10 of a second. Okay. And the rest of the parameters are here. So we need to know how can we use these equations and use the proper parameters and use the proper dimensions. And if there is any rule, for example, the S sub P. The S sub P, this is a pedestrian speed, how many feet per second. They found that average person can walk at a rate of 3.5 feet per second. And this is in this equation here. But on the exam, be careful, they might give you something else. They will tell you, assuming the pedestrian speed is 4.0 feet per second. Okay, or 3.2, whatever the number is. So not necessarily take the default value. If it's not mentioned in the problem statement, for sure you are going to take the default value. Okay, uppercase W, you will find it here, uppercase W. This is the width of the intersection, as we're going to see from curb to curb. And units are very, very important, as I stressed this many, many times in all our sessions. Units, we have to be careful with units, is in feet or inches or meter or seconds or minute and so on. So we have to follow the units that is specified, because some of these equations are empirical formulas and we have to be careful about that. You will find, for example, 64.4. This basically, it is 2g. You know, the gravity acceleration is 32.2 times 2 will give you 64.4. So they put it like that. Some books, they listed this as a 2g. Okay, the uppercase G, which is the this one here, this is a grade. You will find that the plus or minus, because upgrade is positive and downgrade is negative, as all of you know. So what I did, I took this section from the NCSS, the equations, and I start to talk a little bit about each one of them briefly. Okay, based on the references and my transportation books, the one I showed to you, they are available in Amazon. Okay, so I took it and I tried to explain it as briefly as I can. If you would like to study more, you are very welcome to dig in other books or go to the codes and you will be able to read more. But what I'm providing here, I believe, is sufficient for you to prepare for the exam and pass, okay, easily. So for example, here I'm giving you an intersection and I'm talking here, what is the yellow time, which is a Y, okay, in the range of so and so, and they start talk about something we call it, or they call it, the dilemma zone, and the width of the intersection, which is a W, and so on. So the most important thing is to how to use these equations and how to apply the proper parameters. So if you look to the equation, here it is. This is a previous equation. So I took each equation listed and I give it a number. This number, this will not, you will not see. This is my book. This is my discussion, or this is my material. But basically, it is the same material. But I took it and I tried to elaborate on it and explain it a little bit as much as I can. So this is the equation, okay, with all these parameters, okay. Obviously, I put here the 2G, the one I was talking about at least, and you will see what is the grade as. We need to know what's the difference between grade and the slope and the cross slope, okay. So grade, there are three terms we need to be aware of, and I'm sure that all of you are familiar with that, but always I remind you with, so this is the FE7, and also I emailed all of you the notes, FE7, and today is a transportation. If you are missing any of my notes, I encourage you to write after me. But if you miss any, or if you find there is a typo or mistake or an error in my notes, please let me know, because I will be glad to send you the my notes. So there are three terms that we are going to use them today, and we need to be familiar with them as, okay. there is something called the grade G, the uppercase G, and this it could be a plus or minus G grade. Okay, we're going to see this when we talk about vertical curves. So a grade basically how the road or how the facility is going up. They agreed going up is positive and going down is negative. Exactly, they follow the stock market. Anything goes down negative, anything goes down, okay, up is positive. So this is called the grade, okay, G, okay, which is basically the rise over run, okay, and we can find the grade. This is how the road is going up and down. And when we're talking about vertical curves, you are going to see that vertical curves, they have grades, and we're going to see the grades for the sag and for the crest vertical curves. So this is called the grade. So normally we express as a percent. 2%, 3%, and AASHTO, they have minimum and maximum grade, by the way. For example, the minimum grade per AASHTO, as I mentioned before, is 0.3% and 0.5%. This in non-snow areas, non-snow, okay, and this for snow areas, okay, where we have snow, because they need to ensure that the water will, if you have a road that is a flat completely like this. This is called zero grade, flat road. Okay, zero grade does not exist. Zero G does not exist. It's not allowed by the code. Okay, the minimum I have a plus or minus 0.3% or plus or minus 5% in order to allow the water or the rain or if you have a storm or you have something on the road to be moved to take the water away. So they have a minimum grade, minimum grade. So this is called minimum grade, minimum grade. And also there is a maximum, okay, there is a maximum grade. I believe I provided you with 2 tables maximum grade also, because I don't like to have my road like this, plus 10%. It will be very difficult to climb the 10%, or if I go down negative 10% for certain speeds. Obviously there are some grades like this, but I'm saying that they limit the grade with the speed. So the G versus speed is very, very important, and also depends on the type of the facility. If it is a highway or freeway or expressway, county road or mountain road, and they came up with the minimum and the maximum grade, so we can provide safe facilities to the public. This is called the grade. The other term that I needed to be aware of is called the side slope. Side slope, it is used when we build facilities, either cut or fill. If you are in a fill section, you are building a facility like this. Okay, you have a highway or freeway. This is called fill or embankment, as we discussed in surveying. We'll discuss this, and okay, you will find this is a catch point, and this is a hinge point, and this we'll call it the side slope. So the horizontal and vertical. So this is H and this is V. So this is called side slope. And the side slope currently, it is 4:1. 4 horizontal, 1 vertical. This is the minimum. There is no maximum. If you can make it as flat as you can, okay, this will be great. But more flatter side slopes, you need more right of way and more costly projects. But the minimum is 4:1 minimum. And this is again for erosion. The side slope minimum 4:1. They selected this for safety of the public, safety, and for the erosion, okay, in case of water that will spill over. In this case, it will not erode the side slope of this facility. If this is fill or fill, by the way, or we call it embankment, okay? So this is something that I needed to be aware of. The third term, which they have a problem in the NCAAS, the white book, the one I showed you before, is called a cross slope. A cross slope. Cross slope, basically, if you look to the cross section of any facility, if it has a center line, you will find that the road, whatever the number of lanes, you will find that we have the shoulders. So this, we'll call it a cross slope. Okay, normally 2%, and the shoulders 5%. These are the standards per AASHTO. This is for the tangent section, tangent sections. Those are the sections that they are straight line. Okay, it's not super is not on a horizontal curve or spiral curve or anything like that. So these are the terms. And if you remember the problem I showed to you in the NCEES, I hope that you get a chance to buy the book. This book, the NCEES, they have a book. It does have about 100 problems. Let me grab it. This is the white book, the NCEES, the FE practice exam. It does have 100 problems. They are available on the FE or the NCEES website. You are very welcome. So if you look to the last problem, which is the problem number 100, I believe we discussed it here and we'll solve it, but this is just to remind those of you who attended the first time, because I noticed there are new names. You will find that the last problem is talking about the cross slope. They ask you what the cross slope, or what does it mean, this picture, which is this one here. I'm getting close, which is the problem 100. And the difference between this is a problem. No, this is not. It seems to me I have too many books. Let me get if this is the current one or not, because they change. I believe this is the right one. Yes, here it is. Yeah, here it is. So this is a problem that we talked about. Here it is. Problem 100. You see he drew a cross section like this. This is a new cross section, okay, or a road cross section. And they're asking you this, what does it mean, this number here? This number, this is in the book, okay, the white book. If you have the white book, the FE, the current one, okay, the current one, okay, the one they released it last July. If you don't have it, you can purchase it, okay, because we don't have it here, or we don't sell it on our website. We used to sell it on our website, but we are no longer doing that for the time being. So, so the G, the one, I'm going back to the chapter, okay, of the transportation. So equation 13.1. So the second equation they provided is called clearance time for signalized intersection. So if we do have an intersection, and this intersection is controlled by a signal, so they provide this to provide safety to the public. Okay, so because if this direction is green, okay, and obviously the other direction will be red, okay, so the driver or the vehicle here probably hit this intersection while this is yellow. So they need to clear this intersection before they give the green to the other direction. This is called or red. Sometimes we call it or red or a clearance time. Or some books, even they are using the textbook, they are using AR, but the NCEES, they are using lowercase r. Or we're going to see it again in a different location. But what is lowercase or red? Usually rounded to the nearest, okay, 1/10, where all directions will be red, okay, at one point of time. It's called or red in order to clear the intersection, to allow the vehicles on the other direction, when they have the green one, to go through safely. The W is the width of the intersection, width, this W. Okay, and they need to ensure that the car or the vehicle has been left, so they include the length of the vehicle. Length of the vehicle, okay, by the way, the length of the car it varies. We have very wide range, by the way. And the AASHTO, they have two tables. They have the length of each passenger car, single unit truck, multi-unit truck, name it. But for a passenger car, you'll find 19 to 20 feet is normally we use. And the V in this equation, it is the speed, okay, of the approaching traffic, and this must be in feet per second. It must be in feet per second. Okay, so we need to be aware of that. Okay, and we're going to see the conversion, and basically the conversion is 1.47. So if you multiply 1.47 times mile per hour, will give you feet per second. And we are going to see that, and I derived what is the 1.47 coming from. which is 5,200, 5,280, by the way, 5,280, which is how many feet in 1 mile, divide by 6, divide by 60. If you do this, you'll get about 1.47. The third equation included in this section is for pedestrian. We need to, if you have an intersection like this is an intersection, signalized intersection, okay, and the pedestrians are waiting here to cross this. There is a crosswalk, and the crosswalk width should be given to you. So in this case, we need to allow enough green time so the number of people are waiting here to cross this to the other side safely, okay, and this is what the code. They provide only with one equation in the original HCM, the Highway Capacity Manual, by the way, the HCM 2016, they took this equation from there. Okay, so here is the equation which I give it a number 13-3. So those are the three. This is the way I do it for the rest of this chapter, and all the book will be entirely like this. So these equations are given 1, 2, 3. I talk about each one briefly, and after that you will find that. So I talk about this equation here. What does it mean? Okay, and the parameters. Okay, so for example, 3.2, by the way, 3.2, by the way, is called starting up time, because the public is waiting here, or the pedestrians are waiting here. The moment that the signal is green, it will take some time until he start to walk, or the public or the pedestrians start to walk. So they found that the start up time is about 3.2 seconds. L is the crosswalk length, and the S sub P, which as I told you is 3.5 feet per second, but be careful, it might be given to you in the problem differently. And the N, how many people are waiting? Okay, the it's called end pedestrian, the number of pedestrians, okay, in interval. Okay, so how many people are waiting here? Maybe there is a shopping center here. Maybe there is a business here. So we have to consider the green time to be long enough to accommodate the number of pedestrians that will be arriving in one cycle, Okay, all this must be given to you. Okay, so the after this discussion, I provide sample problems or example problems. For example, this section here, I do have 38 problems. So 1338 is the last problem of this chapter. So 38 sample problems, and after that I added what is known as additional practice problems, like exactly like the other chapters or the previous chapters I provided to you guys. So the additional practice problems, these are problems that I encourage you to go over them. Some of them I solve, some of them I leave them blank. Sometimes I leave it blank in order. For example, this problem here, 13.9, I didn't solve it. The stopping side distance is D. This is 1310. It is HSO, the horizontal side offset HSO. We're going horizontal. We're going to see that. Okay, and so on. So I need you to work these problems, and I will be glad to discuss it. I will provide you with the solution, but I need you to do your homework. Okay, because without studying, passing is impossible. Okay, you have to sit and study and do mistakes, and if I can help you, please don't hesitate to ask. So problem 13.1 is given a signalized intersection is located in an urban area. We need to understand what are the given information. Okay, the vehicle approaches speed is 35 miles per hour. The width of the intersection is 24 feet of all approaches. The average vehicle length is 20 feet. The deceleration rate, okay, which is 12.2 feet per second squared. The length of the yellow interval is 4 seconds. Okay, the grade of the road is given. The driver reaction time is given, okay, and is asking what is the driver reaction time. What is the driver reaction time? The driver reaction time, if you look to the equation, okay, the original equation, you will find that the equation, let's go back, equation 13.1, for example, or this T here, this T is the driver perception reaction time, okay? They are saying, okay, normally we take it, okay, at a certain time, how many seconds, but as I told you, based on the problem statement, the driver reaction time. The driver reaction time, because the driver is waiting and it will take some time until he will take his foot from the the brake and put it on the gas. So the given information, and after that you are going to plug it into this equation, and this is a 35 mile per hour, and I convert it to feet per second by multiplied by 50 to 80, and excuse me, let me just this is, or simply the 1.47, as I mentioned, is a conversion from mile per hour to feet per second. After getting the V in feet per second, this is the equation. But after we modify the equation, what does it mean? Because he gave you the yellow time. So if you look at the original equation that's given in the NCEES, you will find that this is the equation. Y is equal T plus V divided by 2A plus or minus 64.4. So he's asking for the perceptual reaction time, which is the T. He's asking for T, not asking for the yellow. So you have to manipulate the equation. And in this case, we did it, and we ended with this 1.65 seconds. And we found that this is the answer B is, and this should match. If you find there is a typo or mistake in my book, please let me know. Okay, so this is an example how to handle this type of problems. And it seems that one of you is asking a question, and somebody is raising the hand. Okay, so as far as the Salim, you are asking about the intersection side distance is coming, and after that let me get the one of you is raising the hand. You are very welcome to raise the hand at any moment. Okay. Excuse me, let me just you are in the air, go ahead. One of you is let me get closer here, and Bernice, and forgive me if I mispronounce your name. Bernice, you are raising your hand. Either by mistake, you raise your hand, you can put it down, you have the control panel. You are in the air. Can you hear me?
Yes, I can hear you. Before I was not able to hear, so I'm hearing you. So thank you, thank you, doctor.
Go ahead and put your hand down. At least I will not. Okay. So I hear. Thank you very much. Yeah, you are very welcome to ask. Okay. So this is the theme of my books, even the 15 books I have. I'm trying to do that. I hope that this is the best approach, or this is the approach that you like. Problem 13-2. Here are the given information, and sometimes they give you more information than what you need. But obviously, you are the one who spend the time and the study, and you know what is required. They give you, for example, the grade 1%. Okay, this grade 1% is positive or negative. Since he didn't put a sign, so the grade is 1%. So G is a plus 1%. Normally, by the default, we take it as 1%. If he didn't mention the negative sign or the positive. So the default is positive unless, okay. And the average vehicle approach, okay, 40 feet per second. He gave you this 40 feet per second. He might give it to you in mph, mile per hour. So you have to multiply by 1.47, but he is nice. Okay. He gave you the width of the intersection, curb to curb 50, which is this uppercase W. Okay. Deceleration rate, 10.0 feet per second square. Speed limit, name it, and standard vehicle length, 18 feet. So all is, and the driver reaction time is 1 second. He gave you a lot of information, and is asking the red clearance interval is most nearly. Probably we can say this is given. We can put the problem here. We can say find, probably like to make it 3 sections, like. So this is what we are looking for. So this is the equation, the R, and this is the equation given. Okay. So the width of the intersection is given to be 50 feet. Here it is. The L is referring to the vehicle length. Here it is. The car, how long and the 40 feet per second is given here instead of mile per hour. A straightforward equation, and we found that the answer B 1.6. Okay, here it is. And I defined the parameters for you, by the way. I define it again, just one more time. Note, the rate clearance intervals is only affected by the intersection clearance length and the vehicle speed, while other information does not affect. This is what I'm telling you. Here it is. I put a note here. It's giving you a lot of information to confuse you. But we need to select what is required only for the equation. So not every piece of information that will be given will be used for the exam. If you flip the page, you will find the problem 13-3. This is an intersection. Sometimes they give you a drawing, sometimes they give you the description of the problem. And we need to know how to translate this into this. This is why the term I'm using, it translate into English. Into English means that always try to do your best to draw something or a sketch or free body diagram or illustration, okay, from the given information. If they give you a drawing, that's good news, okay? So if you look to this problem 13-2, this is a given intersection, and is asking what is the minimum green time for pedestrian traveling in the north-south direction. Here there is a north arrow. Normally it is to the north arrow. North-south direction, so that means that somebody is crossing here. So this, in my calculation, this is W, which is the width of the, the length, the L. Okay, it is the width in the other equation, but in this equation, it's just the length. So this is L. Okay, okay. This is the length that the pedestrian will walk at whatever speed S sub B. Okay, so this is L from here to here. So the L, if you look at it, we can add them. Okay, and this is the equation. As you can see here, I put when the width of the intersection, the width of the crosswalk less than or equal 10 feet, because this equation came from the highway capacity manual, the HCM. Okay, the HCM, they have two equations, so I found it just from the ethical point of view to let you know that this equation is limited, which they provide only with one equation, but there is another equation given in the HCM. I did not include it. I included it in the first printing of this, but I said let me get rid of it because you will not see it. So this is the equation. So all what I need to get what is the minimum green time to allow the people are waiting here to cross safely to the other side of the road. So there it is 3.2 L over L is 76. How did they come with 76? Can you add this, please? Can you add this plus this? If there is a median, you have to consider it. Okay, if you add all these dimensions, 12, 12, 12, did you come up with 76? Okay, if yes, that's good news. If not, please let me know. Divided by 4. What is 4? 4, this is the S sub P. But you are telling me S sub B is all normally the default is 3.5 seconds. But in the problem statement, what did he tell you? Assume the average pedestrian speed is 4.0 feet per second. So not necessarily the 3.5 is the one is going to be used. He might give you something in the problem statement different from the default value. So don't blindly take 3.5. Okay, and the 0.27 and the in pedestrian. In pedestrian, this is the number of people are arriving at any given signal, and he gave it to you. The pedestrian demand 0.9 pedestrian per cycle. Because this signalized intersection is called cycle length, so we're going to talk about this later on. Maybe we're going to touch it a little bit about the cycle length. So this must be given to you, the 0.9. And we found that 22.4 seconds are required. And I found that 22.0 seconds is the best. Okay, you might say, oh, this 22.44, okay, I need to round it. To round it to what? There is nothing really. This is the best number. So try to pick what is the best solution. Looking for the best one. So this is the answer C. It should match this, and it should match this in order. Okay, if you look to the following problem, you will find that it is the same problem, but I did something. I increased the number of pedestrians. So the people are waiting here. It is 8 instead of 0.9 because there is a school here, or maybe there is a business or shopping center. So the number of people arriving, it is 8 per cycle. Obviously, we're expecting the green time should go up. If you remember the problem before, it was 22.4 seconds. We're going to do the same process, and we ended with what? With 27.07 seconds, and this is why I selected the answer D. Obviously, the same equation, and we'll put it here, and we selected the answer D. So the reason I mentioned that, they might ask you a conceptual question. Okay, the minimum green time for a pedestrian traveling at intersection depends on, and he will give you a list of the parameters. What the minimum green time, again, the codes, by the way, codes, okay, be attention the word minimum and maximum. Okay, here the minimum. Can you provide more? You can provide more, but you are going to affect the other direction, obviously, because if you make this green time more or excessive, the people are waiting here, they will not be happy. And this is why we have something called LOS, level of service, LOS. The LOS for signalized intersection depends on the delay, how many seconds you are waiting at the intersection. So we don't like to please one group and hurt the other group, because we need to make a balance between safety and operations. Called safety. Safety is very important, but versus operation. Operation means that we need our facility to work efficiently, okay, without really excessive delay or excessive, okay, or any unsafe situation. So we always make a balance between safety and operation. Okay? And obviously, these two are controlled by something called cost. We are going to see that. This is the first section. The second section of the NCAA is talking about the SSD, stopping side distance, and the intersection side distance. Intersection side distance, they cover it only, they give only one equation. Okay, but in the ASH2 book, we have many, we have case A, B, C, D, E, F, G. We have many cases. Even the case B, it has B1 and B2 and B3, and C, it has C1 and C2. Okay, but here they limit only one equation, one. Okay, so it's called intersection side distance, and you are going to see what is meant by the intersection side distance. Also, you will find that the stopping side distance, there is a table I'm providing here that, this is from my transportation books, there are 4 side distances the code or the ASH2 code is concerned about. Number 1 is called the stopping side distance, SSD. And do you remember we solve a problem about the SSD? Do you remember which problem is that? The problem was related to concrete mix design. And I hope that you receive my note. I hope you understand the problem. If you go to the NCAAS, let me see if I can find the problem. We'll solve it together, okay? And I explain it to you. The one, it has the SSD, which is saturated surface dry condition, okay? This is for the aggregate, the fine, and the coarse. And I explain this. Here we go. Here it is. This is a problem that also they are using SSD. This is a problem number 40 of the NCAAS. But the SSD here is not the stopping side distance here. Okay, this is called saturated and surface dry condition. And we talked about this problem, and we'll solve it together to the best of my knowledge. Explain it very well, and handwritten solution I provided to you. And I told you is a little bit confusing. I clarified for you. And I hope that you understand the subject, okay? And this was in the material section. But here, the SSD, this is called a stopping side distance. This is the minimum distance required to come to a complete stop when you see an object on the facility, any facility, by the all highways, and streets, we must provide enough stopping side distance. There is other side distance, like passing side distance. They don't discuss it here. Decision side distance, also they are not discussed it here. They are not required for you guys. For the transportation BM, yes. Okay. Intersection side distance, yes. So this, they give you equations only for 2. Okay. And the intersection side distance, they give you only one case. One case, which is this equation here. One case. Don't worry about the rest of the cases. And this is what, okay. So I talk about obviously the reading, I will leave it to you. I'm not going to read every single word here because the amount of the material. If you flip the page, this is what the illustrations that I'm providing. What is the stopping side distance? What is the SSD? SSD here is a passenger car, and they found that the average height above the pavement to the driver's eye is 3.5 feet. Yeah, you know, we have SUVs, we have trucks, but they decided to go with the 3.5 feet. The average height of the driver's eye above the pavement. And the object is 2 feet. This is the object. Okay, and they use 2 feet like the height of the rear bumper of a car, or maybe a tire. So if I'm driving and I saw a tire or a mattress or a broken car, I should come to a complete stop. I will take my foot from the gas and I put it on the brake. I should come to a complete stop before I hit this object, the moment I see it. This is called SSD, stopping side distance. This is on a road like this. Okay, if the road, it does have a vertical curve like this. We have a vertical curve. This is called a crest vertical curve. We're going to see that. This is the G1 and G2, by the way, the grade. Do you remember grade? This is G1 and G2. We're going to see how can we use these equations. Okay, so what will happen if I'm driving? This is a flat road, or it's called level road. Level road with the minimum grade, which is a 0.3 or 0.5. Okay, so this is a stopping side distance, the SSD, which it should be provided for all roads. Here I'm providing a picture, okay, for something is called passing side distance, which we'll not discuss it. Passing side distance, we use it only in two-lane highways. Two-lane highways. So you have, but just I left it just in case if the word passing side distance is, okay. So basically, if there is, this is a vehicle here and this is a vehicle here. Okay, this is the first phase, and somebody is driving slowly here, slow, and you need to pass him. So you have to go and speed up a little bit and go to the other lane, the other direction, and come back before the car coming in the opposite direction, okay, in conflict with you. This is called passing side distance, which is passing side distance. Okay, so imagine there is a slow vehicle ahead of you, and you are driving, and you need to pass this. So here I talked about how we measure side distance, or how this is AASHTO, by the way. Everything here based on codes. I don't invent knowledge. Dr. Mansour does not invent knowledge. I am presenting the knowledge given in codes and books, textbooks. I don't invent anything. It's just a matter of getting the information and present it to you. This is why you'll find the difference between one author or one professor to another. And you went to school and you know statics, dynamics, mechanics of materials. The same book can be used by two different teachers, and everybody is presenting the material differently because everybody has his own style of teaching and his own methodology of teaching. This is my methodology based on the 37 years of teaching. I like it that way. I hope that you like it too, and I hope this is helpful to you. So what I'm providing here is not really, okay, my invention, but it's what's written in codes, okay, and textbooks, obviously. Okay, so the criteria for measuring stopping side distance or side distance in general. So they said the height of the driver eye above the road surface, how high it is. And specific object height, what is the height of the object? And if there is any height and lateral position of the obstructions, if there is any obstruction. And they came up with equations. This is the equation that is provided in the NCEES. Here it is. This is the first equation. Stopping side distance is equal 1.47 VT, and the 1.47, by the way, this is the 5280 divided by 6 divided by 60. To convert the MPH, V is the MPH, by the way, V is the speed in MPH, here it is, mile per hour. So they include the conversion factor for you. So don't, okay. T is called driver reaction time. Normally we take 2.5 seconds, but they will give it to you. If not, we take 2.5 seconds is the reaction time. Okay, because the moment I see a tire on the road, or a broken car, or a cow, or mattress, whatever it is, what I'm going to do, I'm going to react. I'm going to take my foot from the gas and put it on the brake. This time is called reaction time. They measured. They found about 2.5 seconds for the average people, old, young, and so on. Okay, and the V is given here to be is the zero speed, and 30. A is called deceleration rate. When you press on the brake, okay, the car will start to decelerate, and the G obviously is a grade, and 32.2 is, so this is called the stopping side distance. And this equation, as you can see, consists of two parts. The first part, which is 1.47 T, this is the distance it traveled during the perception reaction time, the reaction time. So this is the first portion. And the second portion of this, or the second part of this equation, this is the distance it traveled during hitting the brake, because the moment they hit the brake, the car will skid but it travel a distance. So the addition of these two, the perception reaction time distance and the brake distance, is going to be the total of the stopping side distance. And be careful what they are asking for. Are they asking for part number 1 or part number 2? Sometimes they ask for not the total, but okay. Here is another illustration for, and the driver's eye height, they agreed on 3.5 feet, and the object is 2 feet. Problem 13.5. The stopping side distance for a speed of 60 miles per hour of a road, assuming that deceleration is given and the perception reaction. So this is A and T. This is A and this is T. Here is the equation. And here he told you that what kind of road is that? Okay, level road. Level, be careful with keyword, level road. Level road means that it does not have the G part of the equation. This is why we put 0. Even we know the grade, there is nothing is called 0. We have 0.3 and 0.5. But in the equation, they say that level roads, we take the G to be 0. Even we know there is a minimum, the 0.3 and 0.5. But if the grade is given, it should be given to you either positive or negative, and so on. And we're going to see a problem like that. So pay attention to every single word given. If you understand what are the given information, you can apply the equation and you find. We plug in everything and we found this distance. So we select the answer 566. Here it is 565.5. I talked about the grade. Do you remember the grade? I talked about it, okay? And side slopes and all these things I talked about here. So this is a repetition, okay? And if you flip the page, you will find problem 6 and 7. They are in reference to the given information. Obviously, the actual exam, they will have one problem standalone, but here you will see that the given the slope of a segment of a two-lane highway express as a vertical angle and is given to be plus. If you remember in the section of the surveying, the one we covered before, vertical angle, we use the letter V for it. Okay, this is 0, and this is a plus V, and this is minus V. Vertical angle. So these are vertical angles. If you go back to the chapter I covered in the transportation, in the surveying, vertical angle. So he gave me the angle a plus. A plus means above the horizon. So this is a plus. Okay. So what is the percent equivalent grade? What is G in this case? G. And G in this case, it must be what? Plus or minus? It should be plus. Because here it is. Because the road is going this way. So in this case, he gave to you the vertical angle. We know what is the grade is rise over run. Or you can find the tangent, because we know from calculus that if this is y and this is x, what is the slope? The slope is dy by dx, or rise over run, or tangent theta. If this angle theta is known, tangent of the angle is the slope, as all of you know. So I use this and I got the answer. Okay. Problem 7. What is the braking distance? Here is asking for the braking distance only. Okay, the way we use it in the ASHTO, or they are using it in the ASHTO, is called D sub B. Okay, so if you go back again to the equation that provided by the ASHTO, okay, you will find that this equation, going back to, and again, this is on page 298. You are very welcome to go to the ASHTO FE book 10.0. You will find this equation over there. You will find that this is 1.47. This is a braking distance, and this is, this is a perception reaction distance, and this is the D sub B, which is the second part. It's called the braking distance. They are using D sub B, but we call it the braking distance, which I mentioned it. Here I told you that it doesn't have to, this is the D sub B. Okay, so he's asking this problem number 7, is asking for what? Is asking for the D sub B only. So this is the second term. I plug all the numbers. As you can see, the G here, G is very important. G plus or minus, based on the given information, it is a plus, and in this case, plug it, and here it is. And this is, I repeated again the equation, just to remind you that the stopping side distance, and I put something here also. It could be a conceptual question. Say that, as can be seen from the above equation, that the stopping side distance needed on upgrades are shorter than the one on level roads and those downgrade. Okay, so when you are going up, okay, if you go back again to problem 3.5, I needed to understand problem 3.5. This was a level road. And for 60 miles per hour, we found that we need only 566 feet to come to a complete stop. But if you look to this problem here, this is upgrade. This is the 6.12% up. Okay. What you found? You found that it is 2.03 for the D sub B, but if you add to this 1.47 VT, which is to get the total, you will find this distance is much, much smaller than this. Or you can compare it only with the D sub B. This is 345. 345 for this is the D sub B. If you look to this D sub B here is what? Is only 203, because this is going up, because when I go up, I need a less distance because I am against the gravity or against the grade, so the grade is, so I don't need the same amount of the stopping side distance. I need you to understand that. Conception is very, very important, because it could be a conceptual question, not necessarily calculations, and we need to be ready for both. And here it is, another problem to illustrate that. Assuming the perception reaction time is given and so on, okay? But downgrade. Now I'm going down 6%. So this is minus. So I need this distance here. Do you remember the number for flat road? The number for flat road was given here. It is 566. Here I need what? I need 638 feet. It's longer because I'm going down. This is negative. Downgrade. Here he told you downgrade and he put 6%. Downgrade means going down. Downgrade. So we need to know the relationship between all these, just in case if he asks you a conceptual question. If you move to the second side distance, is called ISD, intersection side distance. Sometimes we call it corner side distance. But before that, there is a comment or a section, okay, in the ASHTO. They are talking about, if you remember the height, the eye drive, the eye of the driver, the height, the average is 3.5 feet. So what will happen if we have a truck? A truck, obviously, it is 7.6, by the way, or 8 feet. We are going to see both. 7.6 feet, the truck is higher above the road. 7.6 is the average, or 8 for certain locations. Are going to see it. They are saying that we did not consider the trucks because the trucks have advantage, by the way. This is all this for passenger car. Okay, the truck, they can substantially see further because they are at a higher, so they can see further. So in fact, this will work in their advantage. That's why they consider the height of a passenger car. Intersection side distance. If you have an intersection and there is a car coming in this direction and there is a car coming in this direction, we need to make sure that they are missing each other here because this is a conflict point. They call it this conflict point. Because if these two cars or two vehicles arrive at the same time, they are going to hit each other. This is assuming there is no signalized intersection. Okay, we call it, okay, no control or yield control. Somebody has to come to a complete stop at stop sign or yield, and after that we'll move. But we need to give them enough side distance. It's called corner side distance. Intersection side distance, ISD / corner side distance. This is the official name that's given, but some books they use corner side distance, corner because so we need to make sure there is a sighted triangle, okay, and the sighted triangle they came up with that this triangle here, they call it the sighted triangle. Because this driver here or this driver, they have a line of sight. They should know, they should be able to see each other. So there is no any building or a tree or any obstruction blocking their view. So they took this a triangle side distance and they analyzed it and they came up with series of equations and this is a triangle here, by the way, the sighted triangle, the one I took outside. So I needed to be aware there are two sighted triangles. One they call it, or they actually call it departure, and one is called approach. This is called approach, and this is called departure. So if you look to the approach, there is a vehicle coming in this direction and vehicle coming in this direction. Okay? And this is uncontrolled or yield controlled. So they should be able to see each other. Or maybe coming this way or coming from the other direction. So this width B should be sufficient. So distance B and distance A1 or A2, they should be able to see each other, and the speed on each road should be controlled such that they will miss each other. Okay, this is called approach. The other one is called departure. What's departure? This driver here, this is called the stop control. This driver here, he has to come to a complete stop. And this driver will come to a complete, this is called the minor road. So this is a major road, and this is a minor road. They are going to put a stop sign on the minor road. So the driver on the minor has to come to a complete stop. This is stop sign. Okay. So when he stopped, he should be able to see the car coming from the other direction. The car on the major road doesn't stop. So we need to give enough distance such that this guy, he can either turn left or turn right or go through. These are the three cases, by the way, but we don't discuss here. B1, B2, and B3. This is called the departure. Departure means that a stop sign. There is a stop sign here. Here it is, stop sign there. Here. The same story here. If you stopped here and the car coming from what direction, so this is the leg that we need to look to that. So they came up with one equation. Or sorry, they provide you with one equation. Is intersection side distance is equal 1.47, and again the 1.47 just to convert the 5280 divided by 6 divided by 60 to convert mph to mile per hour. This is why the V, it must be in mile per hour. So don't convert it again. So the ISD, the intersection side distance, with the length of the leg of the set triangle along the major road. I need you to know that we are measuring this distance here. This is a major road. This is a major. I wrote it here, major, but here it is. And the other one is a minor. So this is the length of the leg of the triangle along the major road. Be careful, because this it could be a conceptual question. Is equal 1.47 times V major, because the major will not stop. He is driving with the opposite speed, times T sub G. What is T sub G? T sub G, they call it the gap time, or the time gap. Time gap for minor road vehicle, okay, to enter the major road. And they came up with different time gaps. The 7.5 seconds, 6.5 seconds, 11. They came up with a list of different time gaps, and they have some adjustment, but here they are not going to discuss. So the T sub G must be given to you, because I believe in the original equation is not, or the original table, they did not tell you. Let me wait a second. Here it is. The T sub G, it is a time gap for vehicle entering the road in seconds. So it must be given. There is no default here. So this must be given. This is the AASHTO, the NCSS must be given. Okay, and the sample problem that I gave you here, which is in problem number 13.9, it was given to be 7.5 seconds. Here it is. And this is mile per hour. Don't convert it again, because the 1.47, here it is. And this, I select the answer A, 551 or 555, around it. This is the closest one. The following section is talking about something that's called peak hour factor. Peak hour factor. A peak hour factor is a 15-minute peak volume calculations, and we use it in another section when we're talking about the LOS, level of service. We are going to see this, LOS. So the peak hour factor is given by the following equation: is the hourly volume, which is volume V. Unfortunately, they are using V more than in one location. So V is not the speed, this is a volume, divided by the hourly flow rate. And the hourly flow rate, it is 4 times V15. V15 is a maximum, by the way, which is a peak. The peak 15 minutes, as we're going to see in just a minute. So this is called the peak hour factor. Peak hour factor. Okay, it is a definition that will be used when we calculate the LOS or determine the LOS. I talked about the PR factor. It is the hourly volume during, the volume and so, and this is the equation. This equation came from the HCM, by the way, the Highway Capacity Manual. I give some numerical values here. That typical values 0.8 to 0.95, the high values, in urban and congested areas, and lower values, obviously, for rural or uncongested areas. Here, he's giving you a count for 1 hour. It must be one continuous hour, by the way. So from 4 to 5, the peak hour factor within 1 hour. If he give you more than 1 hour, you have to determine which hour has a peak first, because the 15 minutes must be consecutive 15 minutes. So from 4 to 4:15, they found the volume entering this intersection or this road is 850. And from 4:15 to 4:30 is 950. From this to this, from 4:30 to, and finally the last quarter. So what will be our factor? We add them. This is the sum. This is the hourly volume. The 4 numbers given, I add each quarter. This will give you the total volume within this hour. Divided by 4. This part of the equation, because there are 4 quarters in 1 hour. Times the peak, the maximum. Where is the maximum? It is 1,000. So the 1,000, here it is. This is a 1,000. Because this is the big 15 minute. The highest 15 minute. And it turned out to be 0.887. We take the equation 0.89 based on we pick the number, okay? So this is called peak hour factor, and we're going to see that. If you flip the page, you are going to see the vertical curves. vertical curves. Okay, right now is 9:45 California time. Let's take a few minutes to break. If you can make it only 5 minutes will be good, because I have a lot of material I need to finish it today. So, because vertical curves are very important section. Everything is important, but this is very important. Okay, let's take 5 minutes to break. So right now is 9:45. So 9:50 we are going to meet again. Just get some fresh air or fresh water, and we'll meet again after 5 minutes from now. Stretch your back. Thank you very much. Okay, welcome back everybody after this short break. The following topic here in front of us is the vertical curves. As you know, any facility, either highway or street, we have alignment, and we have two types of alignments. We have horizontal alignment and we have vertical alignment. The difference between them, the horizontal alignment, you are flying over the road or the facility, how the road is turning right or left or straight. So basically, you are flying over the facility. If this is a highway, highway 5 or 605 or 95, whatever highway in your state or in your country, because some of you are from other countries. So you are flying over how the road is moving, winding, right or left or straight. So this is a top view. You are looking from the top. You are flying over the road and take a picture. And this horizontal alignment consists of what? Consists of circular curves, tangents, straight lines, and it might have what is known as a spiral curves. And I will talk about all these when we hit horizontal alignment. Vertical curves, they consist of tangents, and parabolic curves. Okay, parabolic curves. They are not circular curves. We don't use circular curves or spiral curves for the vertical alignment. They decided to use parabolic, one based on the equation y is equal a plus bx plus cx squared. The equation for parabola, but this is a mathematical form. They are using the surveying form or the highway form as we're going to see it. What is a vertical? You are looking to the road as a side view. So you will find that this is G, and they call it G1 is plus, and there is a curve connecting another grade, which is G2 as going down. This is negative and this is positive. If you the intersection of the two grades, they are going to meet at something called V, vertex, or they call it BVI, point of vertical intersection. This is where they are going to intersect here. This curve here is not a circular curve. It does not have a radius. It is a parabolic. This is a parabolic curve, and there is a reason for that. Why they use parabolic, I mentioned them, and there are two reasons for that. The length of this vertical curve is measured horizontally. L here is the distance from the beginning to the end. This is L. This is the beginning of the vertical curve or point of vertical intersection, and this is the end of the vertical curve, which is BVT, point of vertical tangency. These are the notation they are using. And this is a BVI as a 2-point of vertical intersection. All these things are so it's measured horizontally. So we don't really walk along the curve. No, we take the horizontal. This is different from this, by the way. Horizontal curves, the L is measured along the arc. So this is the arc length, as we're going to see later on. So this is a huge difference between the horizontal alignment or horizontal curves and vertical curves. Okay, so we need to know the difference between horizontal alignment and vertical alignment. The one in front of us here, this is a vertical curve or curves. This is from the vertical alignment. So this is vertical alignment. Vertical alignment. And the vertical alignment, if this is the top view for the horizontal alignment, the vertical alignment is a side view. You are looking to the road from the side. Look to the side, how you go up and down. Okay, so we need to be aware of that. We are going to see series of equations, and nobody will ask you to memorize because we have many equations. Nobody will ask you to memorize any equation, but our job here is to know what are these components of these equations or the parameters and how to use them. And if you do have a programmable calculator, again, you need to check with the NCAAS about the calculator policy, what is permitted and what is not permitted, because this is between you and the NCAAS as far as the calculator policy, win the exams. All policies, I don't deal with it, okay? Because my lawyer advised me don't get involved in any, okay? Okay, so this is a vertical curve. It does have a beginning and it does has an end. But they call it here point of vertical curvature and the point of tangency, vertical tangents, BVT and BVC. But this is the beginning of the vertical curve. Some books, they are using BVC, textbooks, and this is the EVC, the end of the vertical curve. And I believe they mention it here also. So the BVC is the beginning of the vertical curve. And the BVT is the end of the vertical curve. Here, but they are using the notations here. So, and this is called back tangent. Back tangent always associated with the beginning. And the forward tangent is always associated with the end, always. We need to maintain the notation they are using. And this is G1, and this is G2. He's using here, or they are using lowercase, but you will find it also, it could be uppercase. It's not a big deal. Uppercase or lowercase is called the grade. This grade. This is the upgrade, this downgrade. The curve, this is the curve, in fact. I prefer if they can draw this as a dotted line, will be, because we don't drive along that. And we have additional like A as an apple, E, and the Y, and the X, and the L. As you can see, the L is measured horizontally, which is this from here to here, is not measured along the curve. And we have a certain datum or reference datum means it will give us elevation, because vertical curves is a side view. So vertical curves will give me elevations of the road. When we build the road, we need to know the vertical curve. So the equations are too many. I will go over them. But again, without going to the swimming pool, you will not really be able to pass the exam. And what's the swimming pool? As I mentioned before, okay? If you give me a couple books about swimming, how to swim, and all the techniques and the pictures are provided in these books, I read them very well. But if I didn't go and jump into the swimming pool, I will never know how to swim. I have to go to the pool. Our pool here is solving problems. If you didn't solve problems and do mistakes and figure your mistakes, I'm sorry to say that is a matter of luck. Maybe if you won the lottery, maybe you will be able to pass. But solving problems, because there are three things normally I tell the engineers for the last 37 years since I'm teaching all these courses, that you need to understand the concept very well. Understand. It's not because I said so or because it's written in one book. No, you need to understand why we are doing this. So understand the concept, because the problems are so tricky. After you understand the concept, million times practice. Practice and practice and practice. There is no limit. If I would like to repeat this million times, I will say it. Solve problems related to the topics only. Okay, what books are available in the market? Whatever books you select, I am not against any book. All books are valuable, but okay, and every book is presenting the material different way. It is your choice, but as long as you practice within the problems that are related to the topics only, don't go beyond that. And this is the problem that some books are available in the market. I have all the books available in the market to the best of my knowledge. Okay, the one I'm aware of, I have it. Okay, some books they go a little bit beyond what is you're supposed to know, or less, or confusing. Everybody is, I respect all the books, and everybody is well respected from my point of view, but everybody is presenting the material from his perspective. So practice. Okay. Number 3, these are called the 3 steps to pass the FE first, and after that you will go to the PE, and you will hear me the same thing. You will, if you decided to, if I'm still alive after you pass your FE. But if you pass very fast or very soon, you may be able, okay, to hear from me. Okay. So the third suggestion from my end is you need to go to the exam with a strategy. The strategy, the 110 problems will be given to you in 5.5 hours. Okay, they give you a break if you decide to take a break. And those who took the exam, they know that. So 110 questions in 5.5 hours. So 5.5 hours, how many minutes is that? So it is 330. So 5.5 hours. So 330 minutes. And you have 110 questions. So about 3 minutes, or exactly 3 minutes per question. And this is CBT, is not paper and pencil. If you don't like the CBT, I'm sorry, this is the only option. 2014, they switch. They are not going to go back. In fact, the PE, they are going to switch it to the CBT also. So the PE, they are going to start this coming October. Most likely will be the last exam that it does have paper and pencil, or using paper and pencil. They are going to switch to CBT. After this pandemic, they discovered that we need to make it sooner than that. Seismic and surveying, as you know, already switched it in 2014. So everybody is using the computer-based screen, and you select the answer, and so you have only 3 minutes per question. So when you read the problem, you have to decide very quick. For example, the problem I showed you, the last problem 100, they provide only 100 in their book for some reason. Okay, probably the 10 questions they put it just for the testing or for statistics, whatever it is. You read the problem, and if you can solve this problem in 3 minutes or less, do it. If you feel that you cannot really finish it in the 3 minutes, I will flag it. The computer will allow you to flag a question. You are going to flag it, and you move to the second question, and you can come back again, but don't leave any question unanswered. All questions, okay, must be answered, because there is no penalty. Okay, there are some exams, they penalize you if you select the wrong answer. So in this case, I'm not sure, I will leave it blank. But here, there is no any penalty. So try to pick what is the best answer and pray to God, and may God accept your prayer if you don't know. But you should know, okay, the majority. So basically, you will find there are some questions are so simple like this. Probably this, if you understand the concept, this is probably a 1 minute question. But if you go to the previous page and you have a problem like this, here it is. You need to read this. And there are some numbers and table and so on. This will take probably more than 3 minutes. So probably I will make this at the bottom of my list. And so on. So there are some questions will take way less than but we're going to see the structure analysis. Structure analysis, for example, this problem 68, this is a continuous beam, okay, statically indeterminate. It has a fixed end here, and roller, and he give you a concentrated load at point C in this direction. And they're asking which combination of moment diagram and deflection shape must accurately correspond to the continuous beam and the loading shown, or with the loading shown. So they give you the answer A. The answer A does have 2 components, deflection and moment, or moment first and deflection. If we understand the concept of what is a moment is, and if we understand what deflection is, and the relationship between them, I will be able to answer it in probably 30 seconds. You will not open a book, any book available in the market, you will not find a problem like this. And always the exam, they come up with no idea. You will not open any book, even if you decided, or if I bought all the books, or if you decided to buy all the books available in the market, okay? Obviously, you are not allowed to take any book with you, except the NCAAS, so you'll not find anything. In the past, even with the open book, you will not find, for the PE, for example, you will not find a problem on the actual exam to match any problem available in any book available. But if I understand the concept, it doesn't make any difference for me what problem they are going to come up with, because this is why I said the concept is very, very important. So please, let us do our best. Going back to the vertical curve, but before I do that, I saw one of you is raising a question here, or raising the hand. Let me see what the question is. We'll see this in just a minute, Salim, about the K. Okay, we'll see what is the K, and we're going to see the K in just a minute. Okay. In the vertical curve, as I told you, this is the tangent elevation. What is a tangent elevation? This is called a tangent. This is a back tangent, and this is a forward tangent. So the tangent elevation means that the elevation along the tangent at any point is equal YBVC plus G1X, and the X is the distance. The distance, by the way, it should be measured from the beginning of the curve. I need you to know that. So the reference for distance is measured from here. This is a reference. Mean all distance measured from the beginning of the curve, or the BVC. So this distance X, and there's another X is called XM for the high and low points. So here is the curve elevation. This is the second equation. What is the curve elevation? These are the elevations of the points along the curve, not along the tangent. So how much is the elevation here? How much is the elevation here? These are points along the curve. And this is the general equation, by the way. Do you remember? This is the equation of a parabola. Y is equal to YBVC plus G1X plus AX squared. And after that, he starts to spell it out. Because the A, this parameter here, is equal G2 minus G1 over 2L, or A over 2L. What is A, uppercase A? Uppercase A is the algebraic difference between the grades. And we take it the absolute value GT minus G1, which is given here. E is called, this E, one unique E is tangent offset at the BVI. By the word offset, we're going to see it twice, by the way. The offset, it could be a horizontal offset or vertical offset. So the offset, the term offset, let me make sure that this is page 2 for some reason. Okay. So the term offset, we are going to see vertical and horizontal. Vertical offset here, we're talking about for vertical curves. The vertical offset obviously is talking about the vertical curve situation, or in the vertical curve. Okay, so this is beginning of the curve, and the curve itself, the end, this is the BVC, and this is BVT, and this is the other tangent, and these are the two tangents which they are going to intersect at the BVI. So this is called the vertical offset, which is using the letter Y, lowercase y. So y, this is the vertical offset. Vertical offset, which is the difference in elevation between 2 points. 1 point along the curve and 1 point along the tangent. So if this is point number 1 and this point number 2, so the vertical offset here is equal y1 minus y2, the difference in elevation. This y1 and this y2. So this will give you the y. There is one specific vertical offset here, we call it E. And they use the letter E, by the way, like external distance for horizontal curves. So E is the vertical offset at the BVI. And he gave you the equation. If you look to Y, okay, in general, the Y, here it is. Y, which is a tangent offset, is equal Rx squared divided by 2, or AX squared. What is R, by the way? R is not the radius. R is called the rate of change grid per station, which is G2 minus G1 divided by L. Unfortunately, in English, we have 26 letters only. So they are using, we're using the R many times, or using D in many times. So what R here is called the rate of change of grade per station. And this R, we're going to see it is positive or negative. It depends on the type of the curve, if it's a sag or crest. So I have series of equations. So this is the R, here it is. And this is a K. What is K? K is called the rate of vertical curvature, which is defined as L over A. And finally, XM. XM is given by this form or this form. Both of them are acceptable. This is the location of the high and low point. This is called XM, horizontal distance to minimum and maximum elevation on the curve. So because we have a vertical curve, we need to know the high and low point. For example, if you do have a bridge, and all of us, we are experience this on a daily basis. You have a bridge, and we're going to see this, by the way. It's called the distance C. And there is a vertical curve here. This is over crossing, and there is a vertical curve. I need to make sure that I have a vertical, it's called vertical clearance, or they call it C, by the way. It's called vertical clearance. Vertical clearance, which according to the standard AASHTO, they ask for 16.5 feet now. But if you drive on any existing roadway or facility or highway, or you'll find 15 and 14.5, because this is all designed. This is why they start to raise all these bridges or lower the road, because the trucks are getting bigger and bigger. So the current minimum vertical clearance is 16.5 feet. The current one, 16.5 feet. This is the minimum based on the new AASHTO requirements. So we need to make sure. But this vertical, we examine it where? At the high point. This is high point on the curve. We need to know to determine how to determine the high point. This distance, if this is a BVC and this is a BVT, they call this distance from here to here XM, which is a distance measured from the beginning. As I told you, the reference is always at the beginning. This is the reference. The high point. This in case of what? What kind of curve is that, by the way? This we'll call it a crest vertical curve. We're going to see a lot of pictures, but any crest vertical curve. If it is a sag vertical curve, a sag, like that, also again, this is a tangent, extend this, and this is another tangent, and this is the beginning, and this is the end. Everything has a beginning and has an end. Like you are studying for the FE, this is the beginning, The end, when you receive an email from the NCAAS, congratulations, you passed. Like 2 days ago, they released the results of the PE, the April exam, and I'm so glad that a lot of my engineers, they passed. A lot of them passed, which is the highest passing rate so far, okay, among all other vendors, which is good news, because they study very hard. Not because I did a good job, no, because they study very hard. Because it doesn't matter what teacher you, or what book, or what course you are taking without studying, okay. So this is a sag vertical cable, we call it sag, and we're going to see, and this is called G1 here, and this is G2 here. They agreed on that. This is down, negative, and this is up, positive. For a sag vertical curve, we need to know what is a low point. Low point. Why we need to, there's also the distance from here to here, they call it what? They call it XM. So the XM is the distance to high or low point, or the maximum and minimum. Because I need to put my drainage system here. I need to put the DI, the drainage inlet, to capture all the water, because we don't like to have a water, okay, on a dip like this. For safety of the public, we need to know where is the low point. So the low and high points are given by what is known as XM, and the XM is given by this equation is equal negative G1 over 2A, or G1L divided by G1 minus G2. So either one of them. And all these, the rest of the parameters are given here. Here, this is the section that I'm providing it in order to explain vertical curves. Why we need vertical curves? Why? Can we have facilities without vertical curves? No. Because if you are in a mountain area, and here is a mountain, here it is. And you asked me to design a new highway for you. I said, oh, I'm going to, here it is. One go up and go down like that. Oh my God. Cheap, yes. But somebody can drive on this all the way hit here. How he's going to come down, my friend? Okay. No, they said, no, this is not acceptable. So in this case, we need to provide a smooth transition between the 2 points. We call it the beginning and the curve. So topography will mandate or will dictate on us to provide vertical curves. Okay. Road makes series of straight lines, and okay, and so on. Parabolic vertical curves. R is G2 minus G1 divided by L is called the rate of gradient. And the reason they're using parabolic, there are two reasons. Number one, R is constant, by the way, for any given curve. And obviously the ease of computations. I'm providing you series tables. Vertical curves could be either symmetrical or asymmetrical or unsymmetrical. Nobody will ask you about this. Yeah, the question that will be here only, or the exam will be symmetrical vertical curves. What does it mean, symmetrical vertical curves? That means that the vertex, if you look to go back again one more page, this BVI, it must be halfway between the beginning and the end. So this is L over 2 and this is L over 2. Not necessarily G1 and G2 will be equal, no. So the symmetrical vertical curves, that the vertex is located halfway between the beginning and the end. Vertical curves could be sag or crest, as we're going to see in the following page. The sag vertical curves, R is always positive. And for a crest vertical curves, R is always negative. Always. So if you did a mistake, you can figure out. And series of illustrations, here it is. This is a crest vertical curve, crest. This is a high point. And this is what they call it XM. Can you put this XM, by the way, just to match? This is XM, the maximum. This is a low point, and this is a high point. I need you to be aware that the high point must necessarily be below this, or the low point to be above the vertex, the BVI, point of vertical intersection. So this is the sag vertical curve, as written here, and this is a crest. AASHTO, the green book, they call it the AASHTO. Okay, this is the newest one, but it's the same figure given in the old one, which is the one they are using right now. They came up with 4 types. For the crest, they call it type 1 and type 2. This is the most common one. For the sag vertical curve, this type 3 and type 4. Here we have one grade is up. This is a plus G1, and this is minus G2. But for this type 2 here, you'll find both of them are positive and both of them are negative. So I don't like you to say, my God, can you have both? Yes. Both positive or both negative? Yes. And the same story. This is negative and this is positive. But here I have 2 negative and 2 positive, but they are still classified to be the sag vertical curve. Okay. So AASHTO, the American Association of State Highway and Transportation Officials, this is what is the AASHTO stands for, American Association of State Highway and Transportation Officials. It's a huge organization, and they have many, many books, and I'm sure that some of you use the AASHTO books, okay? So they have requirements for vertical curves. They must be safe. So I must provide enough side distance, comfortable, okay, no kinks. For example, the short curves. And do you remember the drainage, the 0.5 and 0.3%? Here they are. The minimum. These are the minimum grades, okay, for a drainage. For a drainage, we need to get the water out of the road. So they don't build a road, okay. And here are the geometrics of the parabolic curves, or for the parabola. And this is the equation that we saw. And this is the general equation for a parabola, but they put it that way. This is R. This is the E, which is the tangent offset is given by this equation. And another set of equations here. All these things we need to know that. High and low points, maximum and minimum. Because as I told you, the vertical clearance is very important. So we need to know where is the low point and where is the high point. This is a sag vertical curve. But we need, if they have a pipe here, and some of you already did some project, maybe there is a sewer line or water line or gas line, okay, under the road. We need to make sure that they have a minimum cover. So I need to know where is the pipe and where is a point along the curve in order to provide what is known as the minimum cover. It's called cover, because we need to protect the pipes and or underground facilities in general. This is asymmetrical. This is L/2 and this is L/2. All the vertical curves you are going to deal here, by the way, it is symmetrical. So those are symmetrical. Mean that the vertex or the BVI, it is halfway. L/2 between the beginning and the end. The other one is called unsymmetrical, and I doubt that he will ask you about this on the exam. Again, many equations. Here are, this is the XM that's given in the code or the NCEES. XM is equal the negative G1 divided by 2A. If you find a typo or mistake, please let me know always. I review my stuff, but nobody above mistakes, so nobody above human error or mistakes, including myself. But we need to make sure that we are not, okay, correcting our mistakes. Nothing wrong to do mistake or to do a typo, but let us capture it or let's correct it as much as we can. So many, many equations given. This is the original book. This is the AASHTO. No, again, AASHTO. NCEES, sorry. On page 299, you will find exactly what I presented to you. Equations and definitions and the graph they provide. This is what you will see on the exam. Nothing else you are going to see. Okay? So we need to pick the right equation and the right term, exactly as I said before. So I am providing you with problems. This is a vertical curve. A sag vertical curve has a length, the entering grade and the exiting grade. Sometimes they call it entering grade and the exiting grade. Entering grade is always G1. This is the entering grade. And this is the exiting grade. And they give you for the BVI, the station and the elevation. The station is a distance. Station is a distance, as all of you know. The station is a distance. It could be in feet or it could be in meters. A station. It could be 100 feet or 100 meters. And we need to know how to add or subtract stations. Okay. Before I go to the second page of my notes, okay, I said the offset, we talked about vertical offset. Vertical offset is a distance, or the vertical distance to be more specific. Vertical offset is a vertical distance between 2 points. One point along the tangent, it could be here or it could be here. And we need to know that. Sometimes we need to calculate that. So if this is 0.3 and this is 0.4, so this y here is equal y3 minus the y4. For the horizontal offset, this is related to horizontal distance. I'm driving, okay, here is the road, and here is the horizontal curve. And here are the number of lanes. Let's assume it 2 lanes only. So this is a shoulder, and this is a shoulder, and this is lane this way and lane this way. When you have a tree here, this is a tree, or a power pole, or signal pole. So this tree here, it must be at a certain distance from the ETW, which is, this is ETW, edge of a traveled way, or edge, okay, of the, this distance called horizontal. It's called horizontal offset. So horizontal offset is the horizontal distance between any object like a tree and the edge of the travelway, ETW. I don't like when I'm driving, I need to put all the fixed object far away from the road, because God forbid if you got off the road, we don't like to hit this fixed object, or we have to shield it. We have to put some kind of barrier around it to protect the, but this is called horizontal offset. So I need you to know the term offset is called, one is called vertical offset and one is called horizontal offset. I need you to be aware of that. So this one here, problem in front of us, problem number 1311, I give you the vertical curve and is asking the station of the low point. Okay, this is the G1 and this is G2. As I told you, the low point not necessarily to be exactly above the PVI. It might be if these two grids are equal magnitude, opposite sign, by the way. So this is the equation from where I got this, from the NCEES. XM is equal negative G1 over 2A. A is equal, and I found this distance is, if I use the station, by the way, I prefer, this is station. The curve length is 300 feet, which is 3 stations. I decided to use stations, and the 3.2, which is this grid here, this percent, I drop the percent. This is the most of the surveying books, they are using that. It's much easier to reduce the number of this, because this is exactly like this. A 3.2% negative times the 300. But the 300 in feet. This will give you the same answer as this one here. But you drop the percent and you drop the 100, which is basically are using stations to reduce the number of decimal places, but it is your choice. But the majority of the books, surveying textbooks, because as I told you that I'm teaching surveying also, and they have many surveying books about, I don't know. Because my professor back in Las Cruces in New Mexico, he was the chairman of the surveying department, and when I was doing my PhD, I was teaching surveying. Dr. Brinker. Dr. Brinker is my professor from New Mexico State, in Las Cruces in New Mexico, next to El Paso, Texas, for those who are familiar with this area. This is where I finished my bachelor and my master and PhD from New Mexico State in Las Cruces in New Mexico. Las Cruces is a small community next to El Paso, Texas. So Dr. Brinker was the chairman of the surveying department. We have a very nice, and I learned a lot from him, and still teaching surveying and all these things, and still learning. So anyhow, so you need to, so station, so most of the textbooks, they are using this concept. If you'd like to use feet and you put the percentage, I have no problem with that. Also other books, they do that. Both of them are correct. But it is your choice. But I prefer to use the easy ones, okay? So I got how far the low point from the beginning. As I told you, the reference, this XM is measured from here. This is the reference. So this is the XM. So I found that the low point is somewhere here, exceeding the 150 because the curve is 300, 150 in the middle, by the way. Here it is, 150, because this is symmetrical vertical curve. So my low point is beyond this one here. And this is true, by the way. You will find that this is the low point. So the low point is, this grade here is plus 1.8%. This grade is 3.2% negative. So this grade is steep. This grade is flat. You will find that the low point always, or the high point, is closer to the, or on the low grade or the flat grade, not the steep grade. So if I know this station here, I will add this distance to it. I will get this station here. So how I did that, here it is. I need you to know how to do that. This station is not given, but I know this station here. It is station 30 plus 30. So I took 30 plus 30 minus 150. What is 150? It is half of the curve length. From here to here is 150. So I subtract, and after that I add the distance that, and this is what the answer is. And I have some notes, by the way, to remind you with what I mentioned. So this is the station at the low point. He might ask you what is the elevation, maybe. I believe the next problem. What is the elevation of the low point? So this is the equation. And we plug all the numbers and we ended with this here. This x here, by the way, this x here and this x here, this is the distance from where to where. From, this is a curve, here it is. This is the low point. And this is the beginning of the vertical curve, the BVC. So the x is measured from, again, here. Since I know where is the low point and I know this station, I know x, which is the 1.92 feet. 1.92 station, sorry. So this, we need to be careful about that. And also I need you to know how to do this. This is the elevation of the beginning of the curve. Here it is. The elevation of the vertex is given, elevation 485.92. How can I get the elevation here? I will use this grade and the L over 2. And be careful, this is higher than this. Even this grade is negative, but you will find that I use positive. Here it is. Positive. Don't say, oh, the grade is negative. No, yeah, but the other point is higher than the other. So we need to understand that, and please let me know. Conceptual questions are very important. Okay, and this is an example. Which of the following is not true? Sometimes they ask for what is true and what is not true. What is correct, what is incorrect. Be careful, because sometimes they ask what is not true, and we are looking for the true, because we didn't pay attention to the word not. What is correct and incorrect? What is true and false? Correct or incorrect? Is asking the elevation of the mid-chord point is the average of the elevations of the beginning and the end. The answer is yes, that's correct. What is mid-chord point? This is the beginning of the curve, which is a BVC. And this is the end of the curve, which is BVT. I need you to be familiar with the terminologies they are using. So the beginning and the end. And the stations are increasing this way. If you connect this point with this line, they call this chord. Point A, not the letter A given, is this called mid-chord point. How can I get the elevation of the mid-chord point? This is in the middle, by the way, because this symmetrical vertical curve, 150. Mid-chord point elevation is basically this elevation plus this elevation divided by 2. I need you to be aware of that, this correct statement. The second statement, the vertical curve lies midway between the BVI and the mid-chord point. It means that this distance is equal this distance. The answer is yes. So the vertical curve is midway between. So this vertical curve is the green one here. This distance is equal this distance, by the way. So the answer for item B or statement B is correct also or true. The statement C, I need you to pay attention to that. C is telling you the low point on a sag vertical curve is always at the BVI. They are telling me that the low point is here, always to be here, above. Okay? Is at the BVI. This is not correct. It's not always. It's only in one case. Only in the word always means always. So be careful about keywords on the exams in general, FE exam, PE exam, seismic, surveying, anything, any exam, they always keywords, keyword or keywords. I used to write questions to many boards, so I am familiar with the style they are asking us to do, okay? And also I'm teaching also Fresno State or New Mexico State. So, but specifically for the FE and the EIT, or it's called the EIT before, or the PE, or it's called, okay, so you look for keyword or keywords. So the word always here is a very important keyword. Is it always? No. It might be. If this grid and this grid are equal magnitude, opposite sign, one negative, one positive. And I explain this here for you. And all of the above. Obviously, the two answers are true is only A and B. And answer C is not true. And this is what he's looking for. Which one is not true? And this way I select the answer, okay, C, or the letter C, or statement C is the untrue statement, or not true. Problem number 14, what is the elevation of point A, the mid-chord point? It's a very good problem. Mid-chord point, here it is. Everything is provided here to you. Basically, if I can get this elevation and get this elevation, add them divided by 2, here it is. So I gave you the equation. This is not given in the or the definition of the mid-chord point. This is not given in the NCAAS, but we need to be aware of. So this is 1/2, which is, and we are going to start a new section. What is a new section? The new section is talking about the side distances on curves, a crest or sag vertical curves. We look to the side distance when the road has a grade. The side distance that we covered, the stopping side distance, the SSD. When we said that the SSD, the stopping side distance, SSD, is equal to 1.47 VT plus the V square divided by 30 times A plus or minus 2G times G. And I'm missing one term, if I'm not mistaken. Let me double check, because the equation, sometimes I remember some, sometimes I don't remember all. So this is A over G here, and get rid of this G here. Okay, to make it to match exactly the equation that is given. This is the stopping side distance that we saw before. Okay, where A is the deceleration rate and all these things, and the G is the grade plus or minus. But this is for level roads. If we level roads, we take G is equal to be 0. Or for roads with a plus or minus G. A level road, as I told you, that the one it does has almost 0 grade, or the 0.5, the 0.3, so this we call it level roads. But these roads here, it could be up or down, this positive grade, or negative grade, downgrade. Now we are going to look to the side distance, but if you do have the vertical curves, since we know what are the parameters related to the vertical curves, so we're going to look to the crest and sag vertical curves. So if I have a crest vertical curve, and this is G1, and this is G2, and I'm driving here. I'm driving on this road here, going up. Assume this is a nice car, and there is a broken car here, or a mattress, or a tire, or any kind of incident here. This driver should be able to see this, such that to come to a complete stop. I don't like to go up to this point, and oh my God, there is a mattress. No, I should be able to see. So this is what is meant by the stopping side distance. I should come to a complete stop. And this is expressed here by the AASHTO. This is a graph from AASHTO. My cars is not the best cars in the world, so here it is. This is from the AASHTO. So there is a car driving this way, and there is another car following this. But both of them, they are driving on a curve. So they are saying the driver here has an H1. This is the 3.5 feet. We are going to take it, the height of the driver's eye above the pavement. And he is looking to the tail or the bumper here, this is called H2, which is normally we take it 2 feet. And this is G1, and this is G2. Uppercase or lowercase, as I told you, both of them are acceptable. So the AASHTO, they said that what is the stopping side distance required on a vertical curve? This is the stopping side distance, for example. This one here, by the way, this one here, we're not going to, but this for passing side distance. So we're not going to discuss this because it's not required for you. And you can see for the passing side distance that the H1 and the H2 are equal. Because the driver here it is, and the driver here. This here, this car is moving this way, and the car is moving this way. One in each lane. So I should be able to see the driver's eye, but we're not talking about the passing side distance. We're talking about only the stopping side distance. So they came up with equations. Nobody will ask you again to derive any equation, but if you look to the equation that given in the NCEES, I'm sorry, here it is. Camera is. So this is what is provided to you on page 300. I give you the page number, just if you'd like to go to the NCEES. Okay, series of equations. This is a crest. This is a crest. And this is a sag. And this is a sag. But the sag based on comfort. And the sag vertical curves. So this table, you can say that is divided into two main sections. One section is related to a crest. And the other section is for the sag. And when we need to know which one is talking about. on the exam, sag. So you need to enter the proper section of the table, and we're going to see a lot of tables, by the way, many tables. If you look to the first Crest vertical curves, they have two columns, one S less than or equal L, or S greater than L, where S is the stopping side distance. And the letter A is the algebraic difference in grade. And the H1, as I told you, 3.5 feet. H2 is equal to 2 feet. For the sag, we are going to see the sag equations. This is comfort, and this is C, letter C. C is the vertical clearance. Do you remember the vertical clearance? Told you this is the difference in elevation between the bottom of the bridge and the top of the road. We need to make sure that we have enough vertical clearance so the trucks will not hit the bridges. And probably some of you involved in some projects where the bridges were hit, because these old bridges 14.5 feet and 15 feet, and the trucks are getting bigger and bigger. And this is why they have to have a permit in order to move from one location to another, the drivers, to make sure that we have a vertical clearance. The letter C is a vertical clearance. So we're going to see that. So what's the difference between this equation and this equation? They are essentially the same. This equation here is a general equation where H1 and H2 are included. But if you enter H1 and H2 to be 3.5 and 2 feet, you're getting this. So this is specifically for, so you be careful on the exam. If H1 and H2 to be 3.5 and 2, I will use this blindly. But if H1 and H2 are different from this, I have to use the original equation. This is called the general equation, general. And the same story when S greater than L. How I know that S less than or equal L or greater than L, I don't know. We are going to assume and see if the assumption that I assume is correct or not. Okay? And the same story. This equation is essentially the same, this equation, but this for the H1 and H2 as indicated here. Okay? So let's go to the following page. If you remember the stopping side distance for roads, here it is, SSD. But this is for level roads. Level roads or roads with grades. Roads with grades. Grades means only 1G. The road is going up or going down. But for this, the Crest vertical curve, here I have a problem. I have G1 and G2, which grade I'm going to use. So they came up with these equations to help us. Okay. So if you look to the two equations I'm providing here for 3.5, these two equations are mentioned on the previous page. These are only for the H1 and the H2 as indicated 3.5 and 2. A sample problem. Swimming pool. Number 15. What is the length of the vertical curve to provide a stopping side distance of 650? The grade of the curve is given plus ascending, and descending. Ascending means going up. So plus 4% and minus 2%. And this is a BVI. And there is a vertical curve connecting these two tangents. So this is the beginning of the vertical curve, and this is the end of the vertical curve, which is BVT. And this is L. So here he did not mention anything about H1 or H2. So by default, I will take the H1 and the H2, the 3.5 and 2.0. He didn't mention anything in the problem, so the default values will be the values that will be used. So, and this is a Crest vertical curve based on the given information, yes. And also I tried to draw a sketch or translate into English, as I always say. I will assume, because there are two assumptions here, or two cases, S less than or equal L, or is S greater than L. So I will assume that S greater than L. A is the algebraic difference between the grades. I have 2 and 4, so it is using 6. This is the equation for the S greater than L. Here it is. This is the equation I used based on my assumption. And I enter all the parameters. I ended with L to be this. Remember, I assumed S greater than L. But when I calculate L, 940 is greater than 60. This is not good. I'm violating my assumption. So this solution is acceptable. So I will go with the second assumption, which is S less than or equal L, which is this one here. This equation here, you see? I started with the unacceptable solution first. And it's again, there is, and on the exam, you have to assume one and proceed. There are some other tools we can tell which one is going to control, but they didn't provide it to you in the ASHTO box. We discussed this for the PE. But I start with assumption number 1, not good. Assumption number 2, I enter and I get a length of the S less than or equal L. So in this case, you will find that the L 1174 and the SSD is given. SSD is given to be 650. The stopping said this is, he gave it to you. So this is good. Okay. So my answer is 1174. I found 1180 is the closest one, and this is why this is the minimum curve length. So the second assumption governs. Can you do this in 3 minutes? The answer is yes, if you practice enough. But if you see this the first time on the exam, and you try to read, you try to remember, no. We don't like to go to the exam and say that, as my friend was telling me. I have a friend few years ago, I don't know how many years ago, he told me, Dr. Mansour, I didn't study, and do you think if I go to the exam, I will pass? I told him, no. He told me, but I have some friends, they told me that to go and guess. I told him, that's, you can go and guess, whatever you want, you can, I am not preventing you. He told me, which answer should I pick, A or B or C or D? I told, I don't know, my friend. It is your choice, you are guessing. I cannot guarantee. He told me, but some friends told me that C is a good choice. I told him, again, it is your choice. They are asking me. I told him that. I told you that unless you are extremely lucky and you won the lottery ticket, you may pass, but I cannot guarantee that. Or you have a very low percentage of passing because you didn't study. So he went to the exam and he listened to his friends and he selected C, and results out, and he said that, oh, I didn't pass. I told him, okay, so what's next? He told me that I need to study. I told him, that's good. He told me, but I picked C, and it didn't work out this way. I told him, do you know what C stands for? I told him, see you next time. So don't pick C, okay? Just study, and it may be that C is the correct answer. Maybe, some of them. So without studying is a matter of luck. Don't think that the people who pass, like me or before me or after me, they sit and watch the TV and they pray to God and I will pass, I will pass. No, maybe God will accept your prayer, but you need to study. Okay. This for the Crest vertical curves. For sag vertical curves, they are unique. This is the one going down. They found that when driving at night on sag vertical curves, they found that the light or the headlights, it will hit because you need to see in front of you. And they came up with the criteria after a lot of testing. They looked at that the headlight 1 degree upward angle of the light beam intersects with the surface. They found where the light will intersect. And the car manufacturers nowadays, they do a lot of testing about that also, by the way. When they change the lights, they need to make sure that the lights will be enough for you to see ahead of you, to provide the stopping sight distance, which is S. If there's a broken car here, if there's a broken car here, and I'm going down, I'm supposed to be able to see it, or I see, or a tire on the road, I should be able to see this S. So this is a sag, vertical curve, sag. And do you remember the sag vertical curve? There are three equations. Let's go back again to the table, the one you are going to see on the exam. Sag vertical curves. This for the S less than or equal L. This is S greater than L, we are going to assume. And they came up with something called based on the comfort. Because sag vertical curves, when you go down, especially if you have some kids, okay, if you have kids on the road with you, when you go down, you have two accelerations, the gravitational acceleration and acceleration that's called centripetal force. It's pushing up. This way the kids, they feel that they have been lifted up. Like when you are in an elevator and you are going up very fast, you feel this. So there is a gravitational force which is pushing you, pulling you down to the ground, and they are opposite to each other. So they said that we need to provide a vertical curve to be comfortable to the public. And when you go on a countryside, countryside or county roads, or the winding road, it's like the up and down like this. Like this. This is called, this we'll call it, by the way, we call it rolling terrain. We're going to see it. Rolling terrain, Terri, terrain, rolling terrain. So when you go down like this, ask the kids, okay, they put the safety belt or the seat belt, because I don't like them to hit their head, okay. If you go fast, you'll find that because there's a gravitational force and the centripetal force. This is why they came up with a comfort equation. Here, the third equation we are going to use, or the third for this, for the vertical clearance. This is for the based on adequate side distance under overhead, where you have the vertical clearance for the overpass road or the overpass structure. So if you look to problem number 16, I'm giving you a problem. All these problems, I picked them up from my books, by the way, transportation books. A vertical curve has a grid negative ascending, so that means down, and so negative 4% and plus 2%. This means that this curve is a sag vertical curve. The stopping side distance is given, and V is given also 65 miles per hour. The minimum vertical curve length is most nearly. Do you remember the two assumptions? S greater than L. Here is the equation. I plug the numbers, and I found that the L, it came greater than the stopping side distance. But I'm saying S greater than L, so this is not good also. I started with the no good solution. If you are lucky, you will start with the second one. So I enter S less than L. Here is the equation. And this is good and governs, because in fact S is 650 and S less than the L, the one I got, 947. I check the comfort also, the AV square over 46.5. And I got a curve length to be this amount. This curve is less than what I just calculated. So this will govern. Okay, but if this came greater than this, for example, if you calculate this and you ended with 1,000 feet here, this will, my answer will be 1,000 feet. So I take the larger of the two. I need you to remember that, the larger of the two. The larger of the two answers. Make sense? So this is something very important. I need you to be aware of that. If you flip the page, you will find the vertical clearance equation. Vertical clearance if you have a sag vertical curve, with the two, let me make the vertical curve different color. So this is the beginning of the vertical curve, and this is the end of the vertical curve. And there is a driver here. There is a driver coming down. Big truck, okay? Here there is a bridge. I need to ensure that the line of sight of the driver, his line of sight, it go under the bridge, should be clear, such that if there is any broken car here, he should be able to see it, so he should come to a complete stop. So this is a sight distance S from the driver's eye to the broken car or the fixed object on the road. So I don't like to block his view. If you are driving going down and the bridge cannot, or preventing you, blocking your line of sight, how you are going to see? How you can see from the other side? So we need to ensure that in design. This is called C. This is called the vertical clearance. Vertical clearance, which is, I told you that 16.5 nowadays per AASHTO. Maybe your state, they have lower limit, 16 feet. Some state they are using 16 feet. But this is, it should be greater than or equal 16.5 feet. This is a current standard per AASHTO. So here are the two equations. From where these two equations? These two equations, they are already given to you. I did not really, here it is. These are the two equations. Here it is. The L and the L. One for the S less than L. So the same equations. So if you this English and metric, okay. I'm providing you with the metric, but also, by the way, because the AASHTO, they provide both, by the way. So, but you have this one equation here, sorry, this equation, okay, even it is the same, but this is metric, okay. The second equation given on the following page, which is this one here, he provide you only with the English, okay, which in this case, they are matching because the same parameters, but I provided both of them to you, essentially the same. So, H1 and H2. We said that H1, this one here, H1, what's the H1? This is the driver's eye height, above the pavement height. H2 is the object height, the height of the object, or object's height. This is the only situation, by the way, in the AASHTO, they decided to use H1. They are using 8 feet. The height of the driver's eye in a truck, the average is 7.6. Yeah, 7.6. Because I wrote it here. 7.6, this is the average. But here they decided to use, by the way, the 8 feet. On the exam, he's supposed to give you H1 and H2. This is why the problem, I have a problem number 17. I'm telling you that the driver eye is 8 feet above the pavement surface. Here I gave you two curves. One curve is a crest, and one curve is a sag vertical curve. And here is a bridge. This is curve number 2, by the way. This curve number 2. He said that the stopping side distance based on adequate side under the bridge for the curve 2S is a very good problem. I did not solve it. because you promised me that you are going to sit and study, and I give you four answers. Please work it out, and basically you need to get what is C. You know the elevation here, and you need to get the C. This is the C, the vertical curve, or the vertical clearance, VC. Vertical clearance, or just C, vertical clearance. Very good problem. I didn't solve it, so you promised me that you are not going to go to bed tonight until you solve this problem. Is this promise? Yes, because I need you to pass. Okay. The following one is the horizontal curves. Horizontal curves. Okay, let's take only 5 minutes break. Stretch your back. I know your eyes, you are getting close to lunch and you start to think about lunch. Are we going to go to lunch a circular burger or a square burger? As you know, Wendy's, I believe, is the only provide square burgers. I'm not promoting any business, by the way. I don't provide commercials here. But what's the difference between a circular burger and a square burger? A circular burger, the majority of them are circular because, number one, most of the buns are circular, so they put the buns circular. And also they slice the tomato, also circular. Our mouth is like semicircular. Also, there is advantage of circular burgers versus the square burgers, the heat distribution. You will find that the corners of this square burger may be burned more than the middle one. So they found the heat distribution here is more uniform. This is why the best probably shape of a burger, they found a circular one. Obviously, I'm not going to ask, I'm not promoting, don't eat this or don't eat this because they are not healthy for you and they will keep your eyes, okay, closed. And we need the eye to be open at least 45 degrees. But let's take 5 minutes only and come back because I need to finish the subject before we go to lunch because by the end of this section, whatever it takes, at 12:30 or maybe 1 o'clock at the most, okay? So try to grab a snack if you have a snack nearby, just to eat a little bit to give you an energy to go beyond the 12-hour clock, and we'll do our best. So let us right now is 11:08 California time. Let's make it 11:11. Make it 11:15. What about that? So 11:15. This will give you 7 minutes. Okay, 7 minutes from now. Okay, thank you. Okay, welcome back, everybody. The section in front of us here is related to horizontal curves. And horizontal curves are circular curves or spiral curves. Spiral curves, they provide only one equation. We're going to see it. And I will talk to you about or explain to you the difference between a spiral curve and a horizontal circular curve. But basically, the horizontal circular curve, it has a beginning also and it has an end. So this is the PC, this is a point of curvature, and this is PT, which is a point of tangency. This is the beginning of the curve, the BC, and this is the EC. So they are using also, and is given at the bottom here or under definitions, the BC and the EC. The horizontal circular curve is this arc. So it's taken from a circle. Originally it was a circle. It has a radius R, which is uppercase R, and they took segment from it, an arc, this here. This is a circular curve. So the circular curve basically is a portion of a circle. And also we have equations, we have some definitions and some terms. Obviously the tangent here, by the way, with this we'll call it back tangent. And this tangent here at the end of the curve is called forward tangent. The curve length L is measured along the curve, is the length of the arc. And this is the major difference between vertical curve and horizontal curves. This is called PI, the point of intersection. These two tangents are equal. There is a term called M, middle ordinate. There is a term called E, external distance. And the central angle is called I or delta, which is the same as the deflection angle between the back tangent and the forward tangent. Obviously, this is the I over 2 and this I over 2. And there are two D's, lowercase d and uppercase D. The lowercase d is defined as the angle of the subchord. And uppercase D is called the degree of curve. The degree of curve, we are going to see it shortly, is the arc definition, because we have another definition called chord. And here all these equations are provided to you for the horizontal curves. Again, on the exam, you're supposed to pick the right equation. Nobody will ask you to derive any of these equations. You are very welcome to derive them while you are studying if you want, but it's not required for you to derive an equation. But we need to understand all the parameters in all these equations and use it correctly, because if I misinterpret one or I misplace one instead of the other, obviously I will get the answer, obviously. For example, this here, R is equal 5729.58 over D. The uppercase D is called the degree of curve. Okay, how we define the degree of curve, or how the code or the specs degree of curve. And they are using letter D, uppercase D. And this degree of curve is the arc definition, which we use in highways and streets. There is another definition, it's called chord definition. We use it for railroads and military roads, but we are not going to discuss it here. So what is arc definition? They said if you do have an arc, a curve, that it is 100 feet from the beginning of the curve to the end of the curve, this is the PC, and this is PT. This is the end of the curve, and this is the beginning of the curve. This is a point of curvature. This is a point of tangency. This end of the curve. So, and this, it came up from a circle, so the circle has a radius. Circle has one radius, and this is O, which is the center of the circle. Sometimes, by the way, we call it radius point. Radius point, and you'll see this on a figure I provided to you, radius point. So this angle here, they call it D, the central angle. This is called central angle. The central angle corresponding to an arc length of 100 feet is called the degree of curve. So we know how to proportion things. So if this 100 feet, which it came from a circle, what is the parameter of a circle? 100 feet over 2 pi r. I'm comparing the 100 feet to the circumference as d over 360. Because the entire circle has 360 degrees. We know that. If you solve for r, so r is equal 360 times 100 divided by 2 by d. This is based on just proportioning. Can you do this math for me? So 360, enter 100 times 2 divided and the second by divided. I'm supposed to get this number. Here it is. 5729.58, which is this number of. So the R is equal 5729.58 over D. And this is the equation that they gave it to us. Here it is. R is equal to 5729.58 over D, where D is the degree of curve based on the arc definition. And the rest of the equation, we can derive it, by the way. It's so easy, but nobody will ask you to derive. LC is called long chord. What is a long chord? Long chord is the line connecting the beginning of the curve to the end of the curve. And we have only one long chord for this, is called LC. Here it is. This is LC, which is the distance from here. This is horizontal distance. And they give an equation for that. Okay. And we need to know how to use these equations. LC, here it is. Tangent is equal LC over 2 cosine. All these angles, by the way, all these angles here, it must be in degrees. The angle I or delta must be in degrees, not radians. So there is a lot of parameters here. I need you to be aware of that. And you will not recognize these equations unless you solve many problems. And I'm providing you with, this is the figure I'm using in my books, which is very similar to what was given. Okay, but this, here it is. This is a curve, which is an arc. Sorry, here it is. And this is a back tangent. This is a forward tangent. Delta or I, even they mentioned delta also. These two tangents are equal. And this is a point of intersection. This is called deflection angle, by the way, as we covered in surveying. Do you remember the deflection angle is the angle between two lines? Deflection angle is one of the angles that we talked about in the surveying section. Deflection angle. And as all of you know, as I mentioned, that I asked my assistants, they are helping me to, they put everything for you very easy. So basically, if you go to the, let me see if I can go here and go here and go to our website. Where is our website? Here it is. So if you go to our website, PESE.com, everybody wants to pass his PE. So our website is PESE. Here it is. So basically, here it is. So if you click on this, this is a brochure. But if you like to view the recordings, here it is. If you click on that, it's supposed to take you to the recordings. We store it in 2 different locations. So all these lectures are taught for the FE7. You see, for free. They are available for free. It's just a matter of just buy a popcorn bag or put in the microwave and sit and study, and you will be fine. Click on any of these, you will find that. Okay, so I need you to be aware of that. Okay, so the deflection angle. So if you miss any lecture or you miss in any of these topics, you are very welcome to go and watch it again and again and again. For how long we are going to keep it, I really don't know, but probably for a couple months or so, maybe. Deflection angle. Deflection angle is the angle between 2 lines. If I have a line AB, for example, and line BC, line or course, as we call it, a line or a course. Course. AB is a course and BC is a course, as you remember, for traverse. So the angle between the AB and BC, we call it deflection angle. And this is formed by extending this line like this and rotate this angle. This is a deflection angle to the right. Because deflection angles could be either to the right or to the left. And already I talked about this, but I need you to be aware that deflection angle I'm referring to here, you are going to get my notes if you miss any, by the way. The deflection angle I'm talking about here, if you extend this line, which is the back tangent, and this is a forward tangent, this angle here is a deflection angle. And this deflection angle to the right, by the way. Because the curve itself is to the right. Curves, by the way, horizontal curve could be to the right or to the left. This is to the right. Why to the right? Look to the beginning of the curve. Always we look to the direction of the curve with respect to this. If the curve is turned to your right like this, it is right curve. If the curve is turned to the left, okay, like this one here, let me get another color here. If the curve is turning this way to the left, so we call it this is to the left. So this is to the left or left curve. Because I look to the beginning. If they turn left, left. If they turn right, to be right. And the deflection angle will be following the same deflection angle to the right or to the left. Okay, so we need to be aware. Here are the terms that we talked about: point of intersection, delta or I. All these things are here. And the equations. This is the deflection, the degree of curve. Degree of curve, this is the arc definition. Don't worry about that. This is a core definition. But I included, because this came from my transportation book, so they come together like this. This is a 5728, here it is. And this is how we proportion it, by the way. Here are the equations that are provided by the NCAAS. And these 2 equations are not there. The equations number 26 and 27 are not there. Okay? Are not given in the NCAAS. They assume that you know that. But I include them here. And I put it under this note. A common mistake is to determine the station of the EC, which is the end of the curve, by adding T distance to the PI. Although AC is physically a distance T from the PI, but the distance or the chaining or the must reflect that we are driving on the road, not on the tangent. Let me explain this into English or convert this into English. If I know this station here at the beginning of the curve, I can find the station here by adding L. This is the curve length, here it is, because the stations along the curve. But if I know the station here, the PI station, and I need to find this station, this is T, the tangent, T. T is equal, by the way, if you look to equation, R tan delta over 2. This is the equation. So can you calculate T and add T to this station to get this station? No, you are not supposed to do that. So if you come from here to here by adding T, I'm telling no, you cannot do that. The right way of finding this station, knowing this station, is to come subtract T from here to be here. And after that, you add L. So this is yes, and this is yes, and this is no. Even physically, as stated in the note I'm providing, because this is a common mistake, by the way, and they are going to see a problem shortly. This is physically at a distance T, because these two tangents are equal mathematically. The two tangents must be equal. Otherwise, geometry is no longer valid. No, geometry must be valid, and they are equal. But because when you drive this way and come this way? No. Nobody will drive along the tangent. We drive along this tangent here and enter the curve, and we drive along the curve length. So this here distance is affected by this, not affected by this T only. I need you to be aware of that. This is a very common mistake, and we're going to see problems that it has two answers, because they know our mistakes, and when they give you 4 answers, like this problem here, problem number 18, you will find that one of these answers probably is related to the common mistake that we will do. So, problem number 18 through 21, in reference to the given information. A horizontal circular curve for a new conventional way has the following. It has I or delta and R and the PI station. I encourage you to draw this. This is a translation of what's given. So the PI station is given, the radius is given, the R is equal 1,000 feet, and the I or delta, which is a deflection angle or the central angle, because deflection angle and this angle is delta or I, and if you connect the two radius of this is delta or I also, and this is the center. So this angle and this angle, they're essentially the same, by the way. Deflection angle, mathematically, deflection angle between the two tangents and the central angle, they are equal. And he's asking for what? He's asking problem number 18, what are the BC and the EC stations? So I need to get T. So T is equal R10 delta over 2. Delta is given, here it is. And this is 16:38, 16 degrees and 38 minutes. And all of you have calculators, and we need to make sure that the calculator that we have converting degrees, minutes, seconds. Very easy. Don't divide by 6, don't divide by 60. We need to make sure that whatever calculator you are using, HB or Casio or TI or Sharp, we need to make sure that, I don't like to say divide by 60 and add this. No, especially if you have degrees. So all calculators, they have a way to calculate directly. For example, here it is 1638. For HB, for example, it is 16.38. I enter it like that. And I need it to be degrees. So here it is. I will push one button. The one here, here it is. It is 16.63 directly. This is in degrees. If I take half of it, 0.5 times, here it is 8.3167, which is this one here. This is the delta over 2. If you have Casio, okay, I can show it to you. I do have Casio, I have Sharp, I have the TI, I have TI, obviously the HB, they have different HB35S, HB33. There are many calculators. And as you know, there is a calculator policy. This is based on the website. Go to the NCEES website, calculator policy. You need to know calculator's policy. You need to know which calculator is permitted, because they will ask you to leave. If you use a calculator is not allowed to be on the site, they might ask you, you are not allowed to use it, to use this calculator. So BC and EC. So I got the tangent, and when you read the problem, you should immediately, I need to get this station, which is the beginning of the curve. This is piece of cake, because if I know the tangent and I know this station, subtract t from this will give me this. But I need this station to the end of the curve. That means that I have to find L. And this is what I did. L is equal this equation, or this equation, or this equation. I use one of them, which is 2 pi r delta over 360. And again, this proportion, by the way, I got the curve length L. So here it is. I convert it to stations. This is in feet, this is in station. The PI station is given. This is given. The 60 plus 26, here it is given. I subtracted T, so I went down this way. This will give me the BC station, the 4.80. And if you look to the 4 answers, he gave you the order of the stations, BC and EC. So you'll find 4 plus 80 plus 4 and 4. So if you have only 1 minute left, and you are able to calculate the beginning of the curve, or the BC station, which is 4 plus 80.39, which is these two here. So these are out. And still I need to decide is A or B. But if you don't have time, if you have time, for sure you are going to complete the solution, as we're going to see. But I'm saying that if you have only 1 minute left and you are able to calculate only the BC station, at least you reduce it to 50-50 instead of 25-25, and pick one and pray to God. Maybe you pick the right one. But obviously we need to complete. I need to get L, which is calculated here, and I will add L. So I'm adding the L to the beginning. I ended with 70 plus 70.7, and this is the answer, B as in boy, and here it is. But if I did a mistake, that this station here is given to be 6 plus 26.27, and I know this is T. T is 146, so it is one station, 1 plus 46, okay, 0.18. Can I add these two stations together? Let me add them. If you have calculator, always bring your calculator. At least you can work with me. Number one, you'll get familiar with the calculator, and I highly recommend the 2 calculators. As far as I know, you can carry 2 or 3. As far as I know, always check with the NCAAS. The rules and regulations, I don't involve in NCAAS.org. Those are the people who are administering the exam, and they publish the rules and regulations, and what is allowed and what's not allowed, what's permitted and what's not permitted. Please communicate with them by visiting the website. This will be the best source. Okay? So the 2 calculators, or the 3, if they are, I prefer to have 3. If they allow you to take 3 calculators, I will take 3 just in case if the power or one of the batteries or the one calculator got bad, or so I don't like to lose the exam, because you are studying for 2 or 3 months and you go to the exam. So I don't like you to take any chance of missing the exam because of any problem like calculus. So in this case, if you add these 2 stations, and the adding station is very simple. I say 6.2627, and I enter the 1.46 18 plus, I ended with what? 7 plus 72.45, something like that. 7 plus 72. Okay, so probably if I did this mistake by adding T to the PI station, probably I will pick the answer A. And this is the wrong one. Here it is. I said that. This is a common mistake. So, as I told you, this is the right way to come here and to come here. But if you come from here to here, this is the wrong route. This is the route will really going to affect you, okay? And it will not really provide you with the, so from here to here, from here, by adding T to this, I would say no. This is not allowed. By adding the T to the PI to get the end of the curve, but you have to say yes and yes, and here it is. You write this. All these things will be right, yes, and I hope that you have enough markers and try to provide many notes to remind you with all mistakes or all common mistakes or all. So this is a good problem, and we need. Okay, if you flip the page, you will find that we do have a problem number 19. What is the length of the long chord? Long chord is LC. Do you have a question for LC? Yes, here it is. It's given also in the NCEES. It's just a matter, this is easy calculations. What about the external distance E? What is external distance? The external distance, this is like the offset. Here it is. This is the curve is here and the PI is here. This call it E, external distance. And there is another M, it's called middle ordinate. Middle ordinate. All these things you will get familiar with if you forgot from school or you didn't take surveying class in school or transportation. And I'm sure that you will be familiar with all. External distance, here it is. What is the middle ordinate M? Here it is. Just straightforward calculations. A problem number 22. A circular curve is laid out by deflection angles. The degree of curve is given. This is the arc definition. Sometimes we put A, by the way. I know they did not put A because they are using only one type or one group of the degree of curve, which is the arc definition. So the D is the degree of curve. This is the arc definition. Arc. And the BC station is given, and the BI station is given, and is asking what is the deflection angle at station 13 plus 0, 0. Again, did I provide a drawing here? No. So, as I told you, translate into English. So, if you look to this problem, and I will draw it here under the solution, it translates into English. A circular curve laid out by the deflection angle. There are two methods. I'm going to explain it to you. So there is a curve. He didn't tell me the curve is to the right or the left. It does not make any difference. If he did not mention anything, that means this is a curve to the right. So if this is a back tangent, this is the beginning of the curve or PC, and this is the end of the curve or PT, and this is the tangent here. And these two tangents are going to intercept, or this is a PI. Try to draw as while you are studying, try to draw as nice as you can, just to show you something, okay? And he said that the PC station, this station here is 12 plus 30.5 0.65. And the PI station is 15 plus 43.76. And the degree of curve, D, is given to be 3 degrees. And he is asking, if there is a station here, station 13 plus 00, what is the deflection angle? What's the deflection angle? If I come here and connect the beginning of the curve to this station, we have three things here. This, by the way, we call it subchord. Do you remember the long chord? The long chord is only one chord connecting the beginning of the curve to the end of the curve. We know that. So subchord, we have many of them. But long chord, we have only one, which is connecting it from here to here. This is, it's called LC, the one we solved, long chord. But this little tiny one here is called the subchord. Subchord. And the subchord, if you go to, can you go to the drawing of the NCSS? The subchord, they are using lowercase c, this one here. I know the drawing is a little bit small, but the subchord, which is this one here, lowercase c. And the c, it should be, here it is, the length of the subchord. So this is called the subchord. The problem that I'm drawing here, I hope that you draw it after me, please. This is called the subchord, and this is the letter C, lowercase c. So this is subchord. This is the length of the straight line. This here is arc. This arc is between the station 12 plus 30.65. So this is the arc length. And most important right now, there is an angle, deflection angle. The deflection angle, this is a back tangent, by the way. This is back tangent. I will be glad to include this drawing with my notes, at least since it's color. Probably it will illustrate, or probably it will help you to understand this. Back tangent. If you can read my Egyptian handwriting, would be great. Okay? I try to write as clear as I can. So this arc here, this is the arc length. Okay? Between these two stations, between station 12 plus 30 and 0.65 and this. And we have one angle. This angle between the back tangent and this subchord. This we call it deflection angle. Or let me, because it became so crowded here, let me just move it to the other side and leave station 13 here as is. So this station 13 plus 0. This angle here is called deflection angle. Deflection angle between what and what? Between the back tangent, which is this line here, and the subchord. Here it is. This is the angle I'm talking about. It's called deflection angle. If you look to the NCSS, they give you lowercase d. And lowercase d is the angle of the subchord. But this is the central angle to the subchord. So if I connect my drawing, if I connect, this is the center here. This is O, the center line of this, or the center of this. If you connect this to this, and this to this, this will give you the radius, and this will give you the radius. We know that. But this is the center of the circle, center. Or as I told you, we call it radius point. So far, so good. So if you connect this station 13 by the center, what they said this angle here, we call it D. This is what you see on the, what you will see on the computer on the exam day. I need you to know that this angle here is twice this angle here. This deflection angle here, this is equal D divided by 2. This is what they wrote it on the previous code or previous book, but I don't see it in this. So this is D over 2. So you can calculate D, which I did. Here it is. D, the central angle corresponding to the arc length, is given by this equation. Where is this equation? Here it is. Let's go to make sure that already I'm telling you. Okay, this is D. Where is D? Okay. Here it is. From this equation here, can I solve for D? D is equal to 180 times L divided by pi r. I rearranged the equation. Do you agree with me? Did I do it right? D is equal 180 L divided by pi r. This is the one equation I use here, which is 180 L divided by pi r. 180 L, here it is, 180 L over pi r, exactly. So I calculate the angle D, and it came up to this. I need to get D over 2, which I will take this angle, and this should be the answer. This is in degrees, convert to degrees per second, the answer is A. I need you to know that, okay? Because if you look to the NCEES equations, they gave it to you. I need also you to know something. They didn't mention it here. I mentioned it in my book, or my books. I will show it to you also. This angle from here to here, between the back tangent and the long chord, is half of I over 2 or delta over 2. And this angle from here to here also is I over 2 or delta over 2. If you look to my drawing, I showed you here it is delta over 2 and delta over 2. They must be equal. And this is delta or I. So I need you to understand all these things. So this, the last problem is really, really good problem. A problem number 2022 is a very good problem, and I hope that you are following me. Obviously, I provided none of the above. I don't expect that they are going to add none of the above. Normally they provide for answer, but here just. So this problem is really, really good. Good problem, good. I will say good. Please to understand, try to I will scan this and send it to you with my notes. At least you can, okay. Let me see. Yeah, the subject is too much. It seems to me I'm going to stop here for lunch because the material is still too much. I will not be able to finish it in 1 hour. I know I will squeeze myself as much as I can, but let's take 1 hour lunch and come back after 1 hour from now with open mind and open heart. And I need at least 2 hours to finish it. I was hoping that to finish it by 1 o'clock, but at least I need to at least 2 hours. So you can join me in the afternoon, the same ID, and I will do my best to cover it in 2 hours. Try to make your lunch light, very light lunch, because I need your eyes to be open 100 and 45 degrees at least. Okay, so don't go to the circular burger or square burger, because as I told you, both of them are not healthy and they are not good for you. Okay, so let us come after 1 hour from now, California time, almost at 12 o'clock. So 1 o'clock, we are going to meet again for a couple hours to wrap up this subject, and I'm sure that you will enjoy it. By the end of the day, you'll say, oh, I learned something about transportation. And enjoy your lunch. 1 hour from now, I will be back, and I hope that all of you will be back to join me. And please, 250 calories is good. Is this good? Can you find something 250 calories? Yes, you can. I don't know. A piece of bread will be fine, or a cup of water will be fine. 250 calories. Okay, because I need your eyes to be at least 45 degrees. I need your eyes to be at least 45 degrees. Okay, enjoy your lunch and join me after 1 hour from now. Thank you very much. Okay, welcome back, everybody. It is almost 1:03. I hope the lunch was healthy, and I hope that you found something in the neighborhood of 250 calories. And let's continue our discussion here about the transportation section for the FE civil. The title in front of us here is talking about some topics related to horizontal curves. One of them is called super elevation and spiral curve length and horizontal side offset, HSO. So three equations are provided by the NCEES on page 301. The first equation is related to the super elevation, and the super elevation equation is given in this form, and we will see the super elevation concept in just a minute. So E is called the super elevation rate. E, letter E, super elevation rate. Where can you find this? You remember the horizontal curve. If you go back a few pages, when I talked about the horizontal or horizontal curves, under the definitions, you will find E, which is a super elevation rate percentage. And the super elevation rate, by the way, for your knowledge, it is 4%, 6%, 8%, 10%, and the maximum is 12%. So the maximum super elevation rate is 12% and varies between 4 and 12. So this is a maximum permissible super elevation per AASHTO. Another letter also is mentioned in the same equation is called F, which is a side friction factor. This is the side friction between the wire, the tire, and the wet pavement. They decided to use the wet pavement because you may drive on the roads while it is wet, so the coefficient of friction or the side friction factor will be smaller. R, obviously, the radius. What else I need to mention here? Yeah, those are the. So what is the story behind the super elevation and why it is required? So super elevation is a percent, and as I said, that the super elevation rate between 4% and 12%. The second equation is called a spiral, a transition length, and they gave us this equation L sub S, where L sub S is the length of the spiral, is a 3.15 V cubed over R times C. This C is different from the C we saw this morning, which is a vertical clearance. So do you remember the C? Be careful about that. I know too many equations and too many. This is, if you go back a few pages, figure 13-15, there was a letter C. And the equation that we talked about, it is the problem I told you I need you to solve it. It has the letter C. And also, if you look to the problem 13-17, the one is a blank. I told you I need you to solve it. You will find that we are talking about the C based on the clearance between the bottom of the bridge and the curve. This C in the spiral curve equation, okay, spiral curve equation is called the rate of increase of lateral acceleration. And it is between 1 and 3, by the way. He said that use 1, okay, foot per cubic second cube, unless it is otherwise stated. So the C normally use 1, but you'll see in the discussion that it can vary between 1 and 3. The third equation related to horizontal curves, something is called site distance, but they call it HSO, horizontal site offset, horizontal line sign offset, HSO. And you will see what is the HSO as far as drawing is given by this equation. R times 1 minus cosine 28.6. S is a stopping set distance, by the way, and R is the radius of the curve. So those are the three equations under these three topics related to horizontal curves. And we said that horizontal curves, those are the curves that are either to the right or to the left, and it could be short curve or long curve based on the speed. There is a relationship between. So because our roads or streets or highways, they are not perfectly straight, which is tangent. A tangent section is called tangent section, is a straight line, and we have back tangent and forward tangent, as you know. Tangent, let me complete that. So if we do have a curve to the right like this, so this is a curve to the right, curve to the right, because this is the beginning of the curve, or PC, and this is the radius of the curve, and this is delta or I, the one we talked about before lunch. The central angle, this is called central angle. So if you look to the cross section of the road, if we cut this road, normally this is the center line, by the way. The center line of the road is the one you see it in the drawing. So if you cut the cross section AA, for example, here, let's assume it is one lane in each direction. So if you look to the cross section, you will find that one lane this way, and this is the cross slope, the one we talked about. And the shoulder, normally it does have a steeper slope to take the water out of this facility as soon as possible. So this is the 2%, and this is a 5% shoulder cross slope. So this is the shape of the road along the tangent section, along the straight line. By the way, this point here, we call it PG, profile grade. PG, profile grade. Which is basically, this is the location of the vertical curve. This is where the vertical curve is, by the way. Or the vertical alignment in general, including the vertical curve. This is, it's called PG, profile grade, PG. But as we enter the curve, the road is not going to be like this. And you experience this when you are driving on a freeway and a curve, you'll find that the curve, okay, it does have some impact on the drivers because there is a force trying to push this car outside. As we rotate along the curve, there is a force, centripetal force, trying to push the car outside the road. In order to protect the users or the drivers, we are going to provide super elevation. Super elevation is tilting the road. We are going to raise one side and lower one side. So if you look here, when we have a full super, assuming, because we have a super transition, by the way, it is 1/3 and the 2/3, but we are not going to talk about that. So it's called super elevation transition, because we don't do the super elevation in one step. We do it gradually so the drivers will not feel the impact. But when we have the full super, when the whole road has been rotated, it's called full super, which is the E%, whatever the E value. The E, by the way, is a function of the radius, and the radius is a function of the speed. So at higher speed, you will find that the E is going to be, and there are some tables, and nobody will ask you, but the equation that we are going to see in just a minute about the radius and the super elevation. So if you look to the cross section here, cross section BB, for example, when the road is in full super, so this is the section AA, and you will find better drawings in my section AA, but I need you to get a feeling of it. And there is animation I will show it to you, probably, or I can tell you where it is. At section BB, you will find that the road is like this. This is the center line, and you will find that the two lanes like that, and the shoulders also like that. This is, and this is still the profile grade, and this is going to be the E, whatever the E% is, 10%, 8%, 6%, or the maximum 12%. So the road is tilting like this. This is the high side, and this is the low side. So we are tilting the road such that the car will not be pushed outside. This is the concept of the super elevation. And we cover this in mechanics of materials. Okay, so if you look to the discussion I'm providing, super elevation, according to the law of mechanics, when a vehicle travels on a curve, it is forced outward by a centrifugal force. The purpose of the super elevation, or banking the curve, by the way, it's called banking the curve, is to counteract the centripetal acceleration. I said centripetal force. No, centripetal acceleration is a better, okay, produced, okay, as vehicle, okay, rounds in the curve. Centripetal, okay, acceleration due to the centrifugal force. So this is the drawing that we use in mechanics of materials, where the car, it is on a sloped plane like this, and we have the weight of the car, W, and there's the force here and the friction, and we can analyze this system and we can come up with equation. This is the equation that they provided to us. This equation here, which is 0.01 E plus F, where F is the side friction, is equal V square. V square is the speed divided by 15R, which is this equation here. Nobody will ask you to derive it, but so 0.01 E. The reason they put 0.01 here, so the E, you are going to enter it as if E is given to you on the problem as 8% or 6% or whatever, as long as between 4 and 12. Don't put the percent again, because they put 0.01 here. This is why some books, they said that this is E plus F like that, without putting the 0.01. But the Ashto, this is the Ashto equation, they decided to put the percentage here, so I will enter this as an 8 or 6, that's it, without the percentage again, because we cannot provide double, okay, percentage in this case. So this is the equation that we are going to use, and here are the parameters that involved in this equation. If you flip the page, you will find this is an illustration or a figure 13-18, super elevation transition elements of for a horizontal curve to the right. This horizontal curve is to the right. This is the beginning of the curve, okay, and this is the end of the curve here. This is a tangent section, and this is a curve, and the curve here is to the right, similar to the one I draw. This curve to the right, and this is the forward tangent. This is a back tangent here, as all of you know, this back tangent. Here it is, back tangent, and this is a forward tangent. So the stations are increasing this way. So, and this is the delta or I, and this is R. All these things we talked about. So if you look the transition, we provide the transition before we enter the curve, and a transition along the curve. Normally it is 1/3 and 2/3. So the 2/3 along the curve, 2/3 L, there is something called L sub R, super elevation transition. Don't worry about it. There are equations and tables for that. So 2/3 of L along the tangent and 1/3 of L along the curve itself. And there is another L, by the way, it's called L sub T. L sub T. And also we have equations, and we have also tables to get L sub T. These are the super elevation transitions. Okay, this is called the crown run off, and this is the super elevation transition. But don't worry about it, that L sub T and L sub R, but just, okay. So basically, if you look to the road at section 1, here it is section 1, this is along the tangent. Basically, you will find the cross slope. This is, it's called normal section, normal or tangent section, tangent, which it has a normal cross slope. Here we showed only the lanes, we don't show the shoulder. That's fine, just illustration. And as we enter right now, from point 1 to point 2, section 2, you will find that we bring the outside lane to be 0 slope, 0. This is over the L sub T. This is still 2%. And after that, these 2 lanes, they start to rotate until we reach the maximum super elevation, which is E. So this is the outside lane, and this is the inside lane, or this is this direction here, and this is the direction here. So the outside, this is a PG, profile grade. This, we call it the high side, high, and this is the low side. Okay? High side and low side. Why are we doing that? As I told you, that in order to prevent our cars from flying due to the centrifugal force, okay, or the centripetal acceleration. So I need you to know that what is the purpose of the super elevation. The super elevation is used on horizontal curves only to counteract which of the following forces: a friction between the wet pavement and the tire, a gravitational force, lateral wind force, or the centripetal force. So you'll find the centripetal force is, or the centripetal acceleration. If you use the word acceleration or the centripetal force, they mean the same thing, okay, in this case. Okay, so the purpose of the super elevation or banking the curves, okay, is to counteract the centripetal acceleration produced, okay, as a vehicle rounds on the curve. So I need you to be aware of that. And we do have some discussion in AASHTO about the side friction, and I included some here just for your knowledge. If you flip the page, you will find something is called ball bank indicator, and maybe some of you use it. Ball bank, one of them is mechanical. This is a mechanical one. And this is a digital one. We attach this ball bank to a truck or a car, where the car is on a horizontal plane, and it should read 0. And this is one of them. I have ball bank here. This is one. So when the angle is 0, these angles are degrees. And when the car in a flat surface, 0 slope, is supposed to be 0. It's supposed to read 0 angle, because there is no any. And after that, we start to drive the car on the freeway, on the road or the freeway, and read the angle, and see this angles in degrees, by the way. and see the relationship between the comfort and the degrees. Okay, as the car is tilting more, yourself obviously you experience this when you are in a curve. So AASHTO, they came up with this table. This table is not given in the NCEES, but I provided to you just in case. They are found that the recommended ball bank readings and for comfort speed. They said if the speed between so and so, you're supposed to read this. If the speed is so and so, you read this, and so on. So the this table is established as a relationship between the speed and the degrees of the ball bank. So this is a mechanical one. It's basically we attach it to the vehicle, and when the vehicle is on a surface that is zero slope, they're supposed to be, you see degrees, and after that, as a car tilt this way or tilt this way, we can read the degrees, the inclination of the car. I do have a problem here related to this, just in case if I provide you a table, how to read. He said that field readings of a ball bank indicator were collected for a curve that has a pulse speed of 40 miles per hour. So the curve, they have 40 miles per hour. And we collected the data in this table. What is the most advisory speed for this horizontal curve? So this is the data was collected. When the speed was 20 miles per hour, the reading was 7 degrees. And 25, 10, 30, and so on. So we compare this with the recommended values provided by the AASHTO, the American Association of State Highway and Transportation Officials. So if you look here, you will find that for 20 miles per hour, 14 degrees. We have only 7, so we are fine. For between 25 and 30, 12 degrees. So 25 and 30, I got 11 degrees, 10 degrees and 11 degrees. So this is good. This is okay. This is okay. This is okay. But when we come to the following one, okay, the 35 degrees, here between 35 and 50 was supposed to have 10 degrees. But here for the 35, I got 14 degrees. Oh, this is bigger than the 10 degrees that they provided. So I cannot go beyond that. Obviously, between 35 here, 16, 19. So I will stop here. So, and this is what I explained in the solution. 20 miles per hour, 25, 30 are less than the recommended values given in this table here. Okay. But for a speed of 35 miles per hour, the recorded value, okay, which is 14 degrees, exceeding the 10 degrees, which is recommended by the AASHTO. And this is why even the road, it has a posted speed, they put a sign of 40 miles per hour. Probably we need to revise the sign and say that it is 30 miles per hour curve, because anything beyond that will be not comfort to the public. So this is what is happening. We collect this, okay, in the field and compare it with the standard, and we decide what is going to be the comfort speed for the public, okay, based on the ball bank. Okay, it's called ball bank, and maybe some of you experience that. We go on a truck, and we take the impact of the people, or the impact of driving on a curve using the ball bank and the comfort and so on. But for the sake of the exam, you might get one of these problems, like problem 13-25. This is the equation that's given in the NCEES, the super elevation equation. Say that a road is designed for a traveling speed of 50 miles per hour. The side coefficient of friction is given to be 0.23, and the super elevation is 8%. What is the minimum radius? Okay, so we plug the numbers. So this is the equation. He's looking for the radius. So you need to modify the equation. So the radius minimum is equal the V square divided by 15 times 0.01 F max here it is. If you are looking for V, this is the equation. So I'm providing you, okay, just in case if he gave you a rate and they're asking for the V, here he gave us the V and asking for the R. So if you look for the R, which is this equation here, this is V squared, so 55. Don't change. This is 55 miles per hour. Stay the same it is. Don't multiply it by the 1.47 as we did before. So units are very important. Be careful. Units are very important. So please do not, okay, violate the units. Okay, 15. What is 0.01 E? E, as you can see here, E is given to be 8%. What did I enter here? I enter just 8. Because the 0.01 will take care of the percent. As I told you that some textbook, they don't have the 0.01 and they enter the E by itself. In this case, I have to enter 8%. So it is the same thing. But here they already, this is the percent. I need you to write that because it could be a mistake that you enter 8% again. So 8% times 0.01, that means that double taxation or double percentage, as I always say. So 960, this is a radius. So I selected the answer B. This is the best answer. If you look to problem 26, he gave you a horizontal curve. The design speed is 60 miles per hour. The radius is given. The sat coefficient of friction F is given. What is the super elevation rate? So now we are looking for E. The same equation. It is only one equation given to you. You need to rearrange the equation to determine what the unknown quantity. Here we are looking for E. So R minimum is equal this. Okay. So this is the radius that's given. V is 60 miles per hour. 15.01 E plus 0.12, which is the sat. And solve for E, I get 10%. And I need you to know how to solve this. Okay, I didn't really carry it beyond that, but it is very simple. Just how to solve for E, and I got 10%, and this is why I selected the answer C. Okay, so yeah, so my friend, he was lucky, the one who selected C. This time it came C. This only one C probably so far, I don't know. But so this is the 10%, and this is, we need to know how to this is the equation that's given to you. Let me go back again. Here it is. This is the equation given in this table here. The 0.01 E plus F is equal V squared over 15R. But we need to know how to rearrange the equation in order to determine either R or F or V or E, who will give you all the parameters, and you are missing one. And in this case, we need to rearrange the equation in order to get what is required. The following section is related to one equation, which is L sub S, S for spiral, by the way, is equal to 3.15 V cubed over RC. And this is called spiral a transition length. So, spiral curves. Let me explain to you. So the equation, let me write it here one more time. This when you, so it is 0.01 E plus F is equal V square over 15R. And when I teach mechanics of materials, I talk about this and derive it for them to students, at least they know exactly what. It's very simple derivation, it's not a big deal, but you are not required to. We said that the alignment, again, of roads or alignments, it could be horizontal or vertical. Vertical, this is, we finished it. Vertical, which is basically vertical curves. The sag and the crest, vertical curves. This is the horizontal, vertical alignment, sorry. The horizontal alignment horizontal one. We said it consists of tangent, which is straight line, tangents, circular curves, which is arc, circular curves, and it may contain spiral curves. So tangent plus circular, click on it.